I've read every article about 3-Eye Atlas, and here's what I learned. What I'm about to share with you tonight will challenge everything you thought you knew about visitors from the stars. After diving deep into every research paper, every telescope observation, and yes, even the most controversial theories that had Harvard scientists questioning whether we witnessed our first alien reconnaissance mission, I can tell you that 3-Eye Atlas is far stranger than anyone initially realized. We'll uncover why this object's trajectory defied astronomical probability, why the James Webb Space Telescope detected chemical signatures that shouldn't exist in natural comets, and how a brilliant but controversial physicist convinced half the internet that we might be under extraterrestrial surveillance. But that's just the beginning. The deeper we dig tonight, the more mysterious this cosmic visitor becomes, from its perfectly timed disappearance behind the sun to the explosive conspiracy theories that followed its every move. This is a calm, scientific deep dive, where the most mind-bending discoveries become gentle explorations of cosmic wonder, and I'm your curious scientist, here to guide you through a mystery that gets more captivating with every revelation. Trust me, the longer you stay with me tonight, the more extraordinary this story becomes, building towards discoveries that might just change how we think about intelligence in the universe. If these peaceful explorations of cosmic mysteries help you unwind, it would mean so much to me if you could share a gentle like and perhaps subscribe to join our wonderful community of curious dreamers. I would also love to hear from you in the comments about where, in this beautiful world you're listening tonight, what time it is there. I enjoy responding with interesting discoveries about your local area. One last thing before we start, there's this new hype feature on YouTube. If you click it under the video, it's honestly one of the biggest ways you can support a channel. It makes a huge difference for the platform, for creators like me, and for those of you who enjoy the deep dive documentaries I put so much effort into. Now, let us begin our gentle descent into one of the most extraordinary scientific detective stories of our time. On July 1st, 2025, at precisely 11:37 Universal Coordinated Time, a robotic telescope perched high in the Chilean Andes detected something that would soon capture the imagination of scientists and dreamers alike. The Asteroid Terrestrial Impact Last Alert System, with the wonderfully fitting acronym ATLAS, was conducting its nightly sweep of the heavens when it spotted a faint point of light move diverged against the stellar backdrop in a way that seemed, at first glance, unremarkable. But sometimes, the most profound discoveries begin with the quietest observations. The telescope operators, following standard protocol, recorded the object's position and brightness, assigning it the temporary designation A11PL3Z. In those first moments, no one suspected they were witnessing the arrival of something that would challenge our most fundamental assumptions about visitors from the stars. Think about that for a moment. In our age of constant connectivity and instant information, here was a cosmic messenger that had been travelling through the void for potentially billions of years, carrying secrets from stellar nurseries that existed before our own sun had even begun to shine, and its grand entrance into our neighbourhood was marked by nothing more than a few pixels changing brightness on a computer screen in Chile. The beauty of astronomical discovery lies often in this humble beginning. The universe does not announce its most precious gifts with fanfare. Instead, it whispers them through the patient mathematics of orbital mechanics, the subtle dance of gravitational influence, and the gentle persistence of photons that have journeyed across incomprehensible distances to reach our waiting instruments. Within hours of that first detection, something remarkable began to unfold. Additional observations from telescopes around the world started to paint a picture that was both familiar and deeply unsettling. The object was moving fast, far too fast for anything gravitationally bound to our sun. Its trajectory curved through space in the distinctive hyperbolic arc that astronomers recognize as the signature of an interstellar wanderer, an object that has come from somewhere else entirely and will eventually return to the cosmic ocean between the stars. But here is where our story takes its first curious turn. When astronomers began to trace backwards through archival images, searching for earlier glimpses of this mysterious visitor, they discovered that 3-Eye Atlas had been photographed before, multiple times, dating back to June 14th. The Zwicky Transient Facility at Palomar Observatory in California had captured its image, has had several Atlas telescopes stationed around the globe. These pre-discovery observations revealed something that made seasoned researchers pause and look twice at their calculations. The object had been approaching our solar system for weeks, possibly months, before anyone realized what they were seeing. It had been hiding, in a sense, in plain sight among the countless points of light that dance across our instrument sensors each night. This delayed recognition speaks to something profound about the nature of cosmic visitors and our ability to perceive them. How many other mysterious travelers might be gliding through our neighborhood right now, waiting patiently for the right combination of observation and insight to reveal their true nature? As the mathematical analysis deepened, astronomers around the world began to appreciate the extraordinary nature of what they were witnessing. This was not just another chunk of ancient ice and rock ejected from some distant stellar system. 3I Atlas displayed characteristics that set it apart from its two predecessors, the famous Oumuamua discovered in 2017 and Borisov identified in 2019. Where Oumuamua had been small, dark and enigmatically elongated, and Borisov had behaved like a relatively typical comet despite its interstellar origin, 3I Atlas seemed to occupy a middle ground that was somehow more mysterious than either extreme. It was larger than Oumuamua, potentially much larger, yet it displayed cometary activity in ways that seemed almost restrained, as if it were revealing just enough of its true nature to satisfy our observations while keeping its deeper secrets carefully hidden. The size estimates began at approximately 20 kilometers in diameter, making it potentially the largest interstellar object ever detected. But as more sophisticated observations began to refine these measurements, something curious happened. The estimated size kept shrinking, first to 10 kilometers, then to approximately 5 6/10 kilometers, and some analyses suggested it could be as small as 320 meters across. This shrinking size estimate speaks to the fundamental challenge of studying interstellar visitors. We're essentially trying to understand objects that exist at the very edge of our observational capabilities. Cosmic shadows that reveal themselves only through the faintest traces of reflected sunlight and gravitational influence. But perhaps the most intriguing aspect of 3I Atlas was not what we could measure about it, but what we could calculate about its journey. The trajectory analysis revealed something that sent ripples of excitement and puzzlement through the astronomical community. This object was not following a random path through our solar system. Instead, it was executing what could only be described as a grand tour of our planetary neighborhood, approaching remarkably close to 3 of our most significant worlds. The mathematics were stunning in their precision. 3I Atlas would pass within approximately 29 million kilometers of Mars, sweep past Venus at a similarly intimate distance, and make a relatively close approach to Jupiter, the gravitational giant that shepherds our outer solar system. When astronomers calculated the probability of such a trajectory occurring purely by chance, they arrived at a number that was almost impossibly small. The odds of a randomly oriented interstellar object naturally following such a path were less than 0.005 of 1%. This statistical anomaly began to capture imaginations beyond the quiet halls of observatories and research institutions. In an age when the search for extraterrestrial intelligence has moved from the fringes of science into mainstream academic pursuit, and when government agencies have begun to acknowledge the reality of unidentified aerial phenomena, the possibility that 3I Atlas might represent something more than a natural cosmic wanderer began to seem less like science fiction and more like a legitimate scientific hypothesis worthy of serious consideration. The timing of the discovery added another layer of intrigue to the unfolding story. July 1st, 2025 fell during a period of unprecedented openness regarding the possibility of non-human intelligence. Government UAP reports, congressional hearings, and official acknowledgements of unexplained aerial phenomena had created a cultural moment where questions about extraterrestrial visitors were being discussed with a seriousness and sophistication that would have been unimaginable just a few years earlier. Into this fertile ground of scientific curiosity and cultural readiness stepped a figure who would become central to the 3I Atlas story. Dr. Avi Loeb, the Frank B. Baird Jr. Professor of Science at Harvard University, had already established himself as one of the most prominent and controversial voices in the search for signs of extraterrestrial technology. His previous work on Oumuamua had sparked intense debate within the astronomical community, with Loeb proposing that the object's unusual acceleration and elongated shape might be consistent with artificial rather than natural origins. Loeb's approach to the possibility of extraterrestrial technology was refreshingly direct and unapologetically rigorous. Rather than dismissing such possibilities out of hand, he advocated for what he called the scientific method applied to extraordinary claims. If we are going to search for signs of advanced civilizations, he argued, we must be prepared to recognize those signs when they appear, even if they challenge our preconceptions about how such evidence might manifest. When 3 Atlas appeared in our skies, Loeb saw an opportunity to apply this philosophy to a new and potentially even more intriguing case study. The object's remarkable trajectory, its unusual size and brightness characteristics, and its timing during an era of increased openness to extraterrestrial possibilities all combined to create what he would later describe as a perfect storm of scientific opportunity. But before we delve deeper into the controversial hypotheses that would soon swirl around 3 Atlas, let us pause to appreciate the profound beauty of what we were witnessing regardless of its ultimate nature. Here was an object that had potentially been wandering through interstellar space for millions or even billions of years, a cosmic nomad that had witnessed the birth and death of stars, the formation and destruction of planetary systems, and the slow evolution of our galaxy itself. Think about the journey this mysterious visitor had taken to reach us. It had drifted through regions of space where the temperature approaches absolute zero, where the distance between atoms can be measured in kilometers, and where the concept of weather becomes meaningless. It had been bathed in the radiation of stellar winds from suns that burned and died before our own solar system existed. It had experienced cosmic events that we can barely imagine and carried within its structure the chemical and isotopic fingerprints of stellar processes that occurred in corners of the galaxy we may never visit. And now, for a few precious months, this ancient wanderer was sharing our sky, allowing us to study it, photograph it, and speculate about its origins and nature. Whether it ultimately proved to be a natural comet from another star system or something more exotic, its presence represented a gift of cosmic proportions, a rare opportunity to touch, however briefly, the deep history and vast scale of our universe. The early observations revealed tantalizing hints about what 3I Atlas might be hiding beneath its mysterious exterior. Unlike many comets, which develop obvious tails and comas as they approach the sun and begin to outgas volatile materials, 3I Atlas seemed almost restrained in its activity. It displayed what astronomers described as a fuzzy coma, the characteristic cloud of gas and dust that surrounds an active comet nucleus. But this coma appeared compact and subdued compared to what might be expected from an object of its estimated size. This understated cometary behavior became one of the many small mysteries that would accumulate around 3I Atlas as observations continued. Was this simply the result of an unusual chemical composition, perhaps indicating formation in a stellar environment very different from our own solar nebula? Or did it suggest something more intriguing about the object's internal structure and surface properties? Spectroscopic observations, which allow astronomers to analyze the chemical composition of distant objects by studying the specific wavelengths of light they emit or absorb, began to reveal another puzzle. Initial attempts to detect the standard signatures of cometary outgassing, the telltale spectral lines of water vapor, carbon compounds, and other volatiles, were surprisingly difficult. The object seemed reluctant to reveal its chemical secrets, displaying only subtle hints of the molecular activity that should have been blazing like a beacon as it approached our sun. This spectroscopic reticence added fuel to the growing sense that 3I Atlas was not behaving like a typical interstellar comet, where Borisov had been refreshingly straightforward in its chemical signatures, displaying exactly the kinds of molecular emissions that astronomers expected from a comet formed around another star. 3Y Atlas seemed to be playing by different rules entirely. As news of these anomalies began to spread through astronomical communities and science communication channels, public interest in 3I Atlas began to grow exponentially. Social media platforms buzzed with speculation and excitement. Amateur astronomers around the world began pointing their telescopes toward the constellation Sagittarius, hoping to catch a glimpse of our mysterious visitor. Science fiction writers and futurists began to explore the implications of what it might mean if we were indeed witnessing humanity's first confirmed encounter with extraterrestrial technology. The cultural response to 3I Atlas reflected something profound about our species' relationship with the possibility of contact. Unlike previous interstellar visitors, which had been discovered and studied primarily within the relatively insular world of professional astronomy, 3I Atlas arrived during an era of unprecedented public engagement with space science and extraterrestrial possibilities. Streaming platforms offered documentaries about UFO phenomena. Government agencies released previously classified reports about unidentified aerial phenomena, and respected scientists were openly discussing the search for technosignatures and the possibility of advanced civilizations. This cultural context created a feedback loop between scientific observation and public speculation that had never existed before in the study of the interstellar objects. Professional astronomers found themselves under intense pressure to provide answers and interpretations for observations that were still preliminary and uncertain. The normal pace of scientific investigation, which relies on careful accumulation of evidence and peer review, found itself in tension with a 24-hour news cycle hungry for definitive conclusions and dramatic revelations. Meanwhile, in laboratories and observatories around the world, the real work of understanding 3Y Atlas continued with methodical precision. Additional telescopes were brought to bear on the object, including some of the most sophisticated instruments ever constructed. The Hubble Space Telescope, with its unparalleled ability to capture detailed images of distant objects, was scheduled to observe 3I Atlas during its approach. The James Webb Space Telescope, humanity's most advanced infrared observatory, would train its unprecedented sensitivity on the mysterious visitor. These observations would eventually provide some of the most detailed and revealing data about any interstellar object ever studied, but they would also deepen the mystery in ways that no one anticipated. Each new piece of information seemed to raise as many questions as it answered, creating a puzzle that would challenge our understanding of both natural cosmic processes and the possibility of artificial objects in space. The path ahead for 3Y Atlas would take it on a journey through our inner solar system that would provide multiple opportunities for detailed study. Its trajectory would carry it past Mars in early October, offering a potential opportunity for spacecraft in orbit around the red planet to capture close-up images. It would reach its closest approach to the Sun, called perihelion, on October 30th, at a distance of approximately 130 million miles. But here is where the story takes another intriguing turn. During its perihelion passage, 3Y Atlas would be positioned on the opposite side of the Sun from Earth, making detailed observation impossible from our planet's surface. For several weeks, our mysterious visitor would be hidden behind the blazing disk of our star, invisible to ground-based telescopes and most space-based observatories. This cosmic eclipse would occur precisely when the object should be at its most active, heated by solar radiation and potentially revealing its most secrets through enhanced outgassing and surface changes. The timing of this solar eclipse struck some observers as remarkably convenient for an object that might prefer to avoid detailed scrutiny during its most revealing moments. If 3I Atlas were indeed some form of artificial construct, this period of invisibility would provide an ideal opportunity for activities that its creators might wish to keep hidden from terrestrial observation. This possibility sparked what would become one of the most fascinating theoretical exercises in modern astronomy. Dr. Loeb and his collaborators began to explore the implications of treating 3I Atlas not as a natural object, but as a potential example of extraterrestrial technology. They asked themselves what such an object might be capable of accomplishing during its hidden passage behind the Sun, and what evidence we might look for that could distinguish between natural and artificial explanations for its behavior. The concept they developed was elegant and disturbing in equal measure. An advanced civilization seeking to study our solar system might well choose to disguise their reconnaissance probe as a natural interstellar object. Such a strategy would allow detailed observation of our planetary neighborhood, while avoiding the potentially dangerous attention that an obviously artificial construct might attract. The probe could gather extensive data about our worlds, our technology, and even our civilization itself, all while appearing to be nothing more than an ancient chunk of ice and rock from the spaces between stars. If this scenario were correct, the trajectory of 3Phis Atlas would not be a cosmic coincidence, but rather a carefully planned survey mission. The close approaches to Mars, Venus and Jupiter would provide opportunities to study these worlds in detail, while the Earth flyby would offer a comprehensive assessment of our biologically active planet and its technological civilization. The theoretical framework developed by Loeb and his colleagues was not presented as a definitive claim about the nature of 3Y Atlas, but rather as what they called a pedagogical exercise, an exploration of how we might recognize artificial objects if they were to appear in our solar system. They emphasized that the natural explanation remained far more likely, but they argued that the possibility of artificial origins deserved serious scientific consideration rather than dismissive skepticism. This measured approach to an extraordinary possibility represented a significant evolution in how the scientific community was beginning to think about the search for extraterrestrial intelligence. Rather than limiting such searches to radio signals and optical beacons, researchers were starting to consider the possibility that advanced civilizations might announce their presence through physical artifacts, technological constructs that could be detected and studied using the same observational techniques we apply to natural cosmic objects. The implications of this expanded search strategy were profound. If interstellar space contained even a small population of artificial objects, whether active probes or ancient relics of long-dead civilizations, then every asteroid, comet and interstellar visitor would become a potential archaeological artifact worthy of detailed technological assessment. The universe itself might be filled with evidence of intelligence, hidden in plain sight among the countless natural objects that populate the cosmic environment. But even as these theoretical possibilities captured public imagination and sparked intense debate within scientific communities, the observational campaign to study 3I Atlas continued with relentless precision. Ground-based telescopes tracked its motion across the sky, measuring its position with ever-increasing accuracy and monitoring its brightness for signs of variability that might reveal rotational surface features. Space-based observatories prepared for detailed spectroscopic and imaging campaigns that would provide unprecedented insight into its composition and structure. The Hubble Space Telescope captured what would become some of the most iconic images of 3Y Atlas, showing it as a bright point source surrounded by a subtle but clearly visible coma of gas and dust. These images provided crucial evidence that the object was indeed behaving like a comet, releasing volatile materials as it approached the Sun and warmed under solar radiation. Yet even these confirmatory observations contained subtle anomalies that kept the mystery alive. The coma appeared unusually compact and symmetric, lacking the typical tail structure that develops as solar wind pushes cometary debris away from the Sun. The object's brightness varied in ways that were difficult to reconcile with simple rotation of an irregularly shaped nucleus, and spectroscopic observations continued to show only weak and ambiguous signals from the expected cometary molecules. These observational puzzles created a perfect storm of scientific uncertainty and public fascination. Here was an object that looked enough like a comet to satisfy the basic requirements for natural classification, yet displayed enough anomalies to keep alternative explanations viable. It existed in that fascinating liminal space where rigorous science meets the boundaries of the known, where careful observation encounters phenomena that challenge our existing theoretical frameworks. As 3I Atlas continued its approach toward the inner solar system, the stakes of understanding its true nature seemed to grow with each passing day. If it were indeed a natural object, it represented an unprecedented opportunity to study the composition and structure of material formed around another star, potentially billions of years ago. The chemical and isotopic signatures locked within its structure could provide crucial insights into stellar and planetary formation processes in distant corners of our galaxy. But if the more exotic interpretations proved correct, if 3I Atlas represented humanity's first confirmed encounter with extraterrestrial technology, then its study would mark the beginning of an entirely new chapter in our species' relationship with the cosmos. We would no longer be alone, no longer unique, no longer the only intelligence attempting to understand and explore the universe around us. The weight of this possibility began to permeate discussions about 3I Atlas in ways both subtle and profound. Media coverage grew increasingly sophisticated and nuanced, moving beyond simple sensationalism to explore the genuine scientific and philosophical implications of the various interpretations being proposed. Government agencies quietly began to take notice, though their involvement remained largely behind the scenes and out of public view. Educational institutions found themselves grappling with how to present this unfolding story to students and the public. How do you teach responsible scientific skepticism while remaining open to extraordinary possibilities? How do you navigate the tension between rigorous methodology and the recognition that our universe might contain phenomena that challenge our most fundamental assumptions? The Three-Eye Atlas controversy became a case study in how modern science operates at the boundaries of the known. It demonstrated both the power and the limitations of our observational capabilities, the importance of maintaining multiple working hypotheses when dealing with ambiguous evidence, and the challenges of conducting rigorous research in an environment of intense public interest and speculation. As we continue our gentle journey through this cosmic mystery, let us pause for a moment to appreciate the profound questions that Three-Eye Atlas was forcing us to confront. What does it mean to be alone in the universe? How would we recognize evidence of extraterrestrial intelligence if it appeared in our sky? What responsibilities would we bear if we discovered that we were indeed being observed or studied by intelligences from other worlds? These questions touch on some of the deepest aspects of human nature and our relationship with the cosmos. They speak to our fundamental need to understand our place in the universe, our fascination with the possibility of contact with other minds, and our hopes and fears about what such contact might mean for our future as a species. The story of Three-Eye Atlas cannot be fully understood without appreciating the broader context of humanity's evolving relationship with the possibility of extraterrestrial intelligence. For decades, the search for life beyond Earth had been dominated by two primary approaches. Radio astronomy projects like SETI scanned the skies for artificial signals, while astrobiologists studied extreme environments on Earth and analysed the atmospheres of distant exoplanets for biosignatures that might indicate the presence of living worlds. But by the mid-2020s, a third approach had begun to gain serious scientific credibility: the search for technosignatures, evidence of advanced technological civilizations, was expanding beyond radio waves to include the possibility of artificial structures, spacecraft, and even archaeological artifacts that might be detectable using conventional astronomical observations. This evolution in thinking had been catalyzed partly by the discovery of Oumuamua in 2017. When that first confirmed interstellar visitor displayed acceleration that could not be easily explained by gravitational forces alone, some researchers began to wonder whether we were witnessing our first encounter with extraterrestrial technology. While the scientific consensus eventually settled on natural explanations involving outgassing of unusual volatile compounds, the episode had opened a door that could never again be completely closed. The possibility that interstellar space might contain artificial objects had profound implications for how we think about cosmic archaeology and the search for intelligence. If advanced civilizations had been exploring our galaxy for millions or billions of years, they might have left traces of their presence scattered throughout interstellar space. Ancient probes, failed colonization attempts, or even deliberate markers intended to be discovered by emerging civilizations like ourselves could be drifting through the cosmic void, waiting for the right combination of technology and curiosity to reveal their true nature. This perspective transformed every unusual astronomical observation into a potential archaeological discovery. Asteroids with unexpected compositions, comets with anomalous behavior, and interstellar visitors with puzzling characteristics all became candidates for technological assessment rather than purely natural classification. When Three-Eye Atlas appeared in our skies carrying its cargo of observational anomalies and statistical improbabilities, it arrived into this evolving intellectual landscape like a perfectly timed test case. Here was an object that demanded the full attention of our most sophisticated observational capabilities, yet remained ambiguous enough to support multiple interpretations, ranging from the completely conventional to the utterly extraordinary. The mathematical analysis of its trajectory remained one of the most compelling aspects of the Three-Eye Atlas mystery. When astronomers calculated the object's path backwards through time, Tracing its journey from the depths of interstellar space into our solar system, they discovered something that challenged the traditional understanding of how cosmic visitors typically behave. Most interstellar objects follow trajectories that are essentially random with respect to the structure of planetary systems. They arrive from arbitrary directions, pass through our neighbourhood at arbitrary angles, and depart toward arbitrary destinations. This randomness reflects the chaotic nature of the ejection processes that originally expelled them from their home systems, combined with the gravitational influences they encounter during their lengthy journeys through interstellar space. 3Y Atlas, however, appeared to be following what could only be described as an optimal reconnaissance trajectory. Its path would carry it past multiple planets at distances ideal for detailed observation, while its orbital inclination kept it roughly aligned with the ecliptic plane where most solar system activity occurs. If someone had deliberately designed a trajectory for studying our planetary neighbourhood, they could hardly have chosen a more efficient path than the one 3I Atlas was naturally following. This realization led to one of the most fascinating theoretical exercises in modern astronomy. Dr. Loeb and his collaborators began to explore what they called the reconnaissance hypothesis, the possibility that 3I Atlas represented an intentionally designed survey mission rather than a random cosmic wanderer. The reconnaissance hypothesis was built upon several layers of observational evidence and theoretical reasoning. The trajectory analysis provided the foundation, demonstrating that the object's path through our solar system was statistically extraordinary in its apparent intentionality. The size and brightness characteristics added another layer, suggesting an object that might be larger and more reflective than typical cometary nuclei. But perhaps, most intriguingly, the timing of the 3I Atlas encounter seemed to align with what an advanced civilization might consider an optimal moment for reconnaissance of our world. The mid-2020s represented a unique period in human development, a time when our technological capabilities had advanced to the point where we could detect and study interstellar visitors. Yet our space-based infrastructure remained limited enough that detailed inspection of such objects would be challenging. An intelligence seeking to assess our civilization might choose precisely such a moment for reconnaissance, when they could gather comprehensive data about our technological capabilities while minimizing the risk of their own activities being detected or understood. The 3I Atlas flyby would provide opportunities to study our radio emissions, observe our spacecraft and satellites, and evaluate our responses to the detection of an unusual object in our sky. The theoretical framework developed around the reconnaissance hypothesis was careful to maintain scientific rigor while exploring extraordinary possibilities. The researchers emphasized that they were not claiming 3I Atlas was definitely artificial, but rather that the artificial hypothesis deserved serious consideration alongside natural explanations. This measured approach reflected a sophisticated understanding of how science should operate at the boundaries of the known. When confronted with phenomena that challenge existing paradigms, the appropriate response is not immediate acceptance or dismissal, but rather careful analysis that maintains multiple working hypotheses until sufficient evidence emerges to support definitive conclusions. The reconnaissance hypothesis also drew upon insights from a fascinating branch of theoretical astrobiology known as the dark forest theory. Originally popularized in science fiction by author Liu Cixin, the dark forest concept proposes a solution to the famous Fermi paradox, the question of why we have not yet detected obvious signs of extraterrestrial civilizations, despite the apparent likelihood that they should exist. According to dark forest theory, the universe may indeed be filled with intelligent civilizations, but these civilizations remain deliberately hidden from each other, because contact between species inevitably leads to conflict and destruction. In such a universe, survival depends upon remaining undetected while carefully monitoring potential threats and opportunities. If dark forest conditions prevail in our galaxy, then any extraterrestrial intelligence encountering our solar system would face a complex strategic calculation. They would need to gather information about our capabilities and intentions, while avoiding detection that might provoke a hostile response. A reconnaissance probe disguised as a natural interstellar object would represent an elegant solution to this intelligence-gathering challenge. The probe could conduct detailed observations of our world and civilization, while appearing to be nothing more than an ancient chunk of ice and rock from the depths of space. Even if we detected and studied the object extensively, its artificial nature would remain ambiguous enough to avoid triggering alarm or aggressive responses. This theoretical framework provided a compelling context for understanding the apparent anomalies surrounding 3I Atlas. The unusual trajectory could represent careful navigation rather than cosmic coincidence. The restrained cometary activity might reflect technological control rather than natural processes. The timing of the encounter might be strategically chosen rather than randomly determined. Yet even as these extraordinary possibilities captured public imagination and sparked intense scientific debate, the observational campaign to understand 3I Atlas continued with methodical precision. The summer of 2025 became a season of unprecedented international cooperation in astronomical observation, as telescopes around the world coordinated their efforts to extract every possible piece of information from our mysterious visitor. The Hubble Space Telescope provided some of the most detailed and revealing observations of 3I Atlas ever obtained. On July 21st, Hubble captured images that showed the object surrounded by a clearly visible coma of gas and dust, confirming its cometary nature while simultaneously revealing puzzling details about the structure and behavior of this surrounding material. Unlike typical comets, which develop elongated tails that point away from the Sun due to solar wind pressure, 3I Atlas displayed what appeared to be a more compact and symmetrical coma. The material surrounding the nucleus seemed to form a roughly spherical cloud, rather than the characteristic teardrop shape expected from solar wind interaction. This anomalous coma structure became another piece of the 3I Atlas puzzle, suggesting either unusual physical properties of the nucleus material or possibly non-standard processes governing the release and distribution of gas and dust. Some researchers speculated that the symmetric coma might indicate rotation characteristics different from typical comets, while others wondered whether it might reflect artificial control over outgassing processes. The Hubble observations also revealed subtle variations in brightness that could potentially indicate surface features or compositional differences across the object's nucleus. However, the resolution limits of even our most advanced telescopes meant that 3I Atlas remained essentially a point source, its detailed structure hidden behind hundreds of millions of miles of intervening space. As the summer progressed, and 3I Atlas continued its approach toward the inner solar system, additional observations began to flesh out the picture of this mysterious visitor. Ground-based telescopes equipped with advanced spectrographs attempted to detect specific molecular signatures that could reveal the object's chemical composition and confirm its cometary nature. These spectroscopic observations proved surprisingly challenging and ambiguous. While some weak signatures consistent with cometary molecules were eventually detected, they appeared at much lower levels than expected for an object of 3I Atlas's estimated size and distance from the Sun. The spectral evidence suggested an object that was behaving like a comet, but a very restrained and subtle one. This spectroscopic reticence added another layer to the growing mystery surrounding 3I Atlas. Natural comets typically become increasingly active as they approach the Sun, releasing growing quantities of gas and dust that create obvious spectral signatures and visible tails. 3I Atlas seemed to be following a more conservative approach, revealing just enough cometary behavior to confirm its basic nature while keeping its deeper characteristics carefully concealed. The restrained activity patterns observed in 3I Atlas sparked discussions about possible explanations ranging from the mundane to the exotic. Perhaps the object had formed in an unusually cold region of its original stellar system, leading to a composition dominated by materials that sublimate only at very high temperatures. Perhaps its surface had been modified by cosmic ray bombardment during its interstellar journey, creating a protective layer that inhibited normal outgassing processes. Or perhaps, as the more speculative hypotheses suggested, the controlled activity patterns reflected artificial management of the object's observable characteristics, designed to maintain the appearance of natural behavior while avoiding detailed revelation of internal structure and composition. Meanwhile, preparations were underway for what promised to be the most sophisticated spectroscopic analysis of any interstellar object ever attempted. The James Webb Space Telescope, humanity's most advanced infrared observatory, was scheduled to observe 3I Atlas during its approach through the inner solar system. Webb's unprecedented sensitivity and spectroscopic capabilities offered the potential to detect molecular signatures that had never been observed in interstellar objects before. The telescope could search for exotic ices that might have formed in the cold depths of interstellar space, identify isotopic ratios that could reveal the stellar environment where 3I Atlas originated, and potentially detect any artificial signatures that might distinguish technological artifacts from natural objects. The anticipation surrounding the Webb observations reflected the broader excitement and anxiety that had begun to surround the 3I Atlas encounter. Here was a situation where humanity's most advanced scientific instruments would be brought to bear on an object that might represent either a fascinating natural phenomenon or something far more extraordinary. The cultural response to 3I Atlas continued to evolve in fascinating ways as the summer of 2025 progressed. Social media platforms buzzed with speculation and debate. Amateur astronomers shared images and observations, and science communication channels found themselves grappling with how to present a story that remained genuinely ambiguous and open-ended. The 3I Atlas phenomenon demonstrated something profound about how scientific discovery operates in the modern age. Unlike previous eras, when major astronomical discoveries remained largely confined to professional communities until definitive conclusions emerged, the 3I Atlas story unfolded in real time before a global audience hungry for updates and interpretations. This unprecedented transparency created both opportunities and challenges for the scientific process. On one hand, the public engagement with astronomical discovery had never been more sophisticated or widespread. Millions of people around the world were learning about orbital mechanics, spectroscopy, and the search for extraterrestrial intelligence through their interest in 3I Atlas. On the other hand, the pressure for immediate answers and dramatic conclusions sometimes conflicted with the necessarily cautious and methodical pace of rigorous scientific investigation. Researchers found themselves navigating between the legitimate excitement surrounding their work and the need to maintain an appropriate scientific skepticism about preliminary and ambiguous observations. The 3I Atlas story also highlighted the evolving relationship between professional astronomy and public participation in scientific discovery. Amateur astronomers around the world were contributing meaningful observations and analysis, while citizen science projects enabled broader participation in data analysis and interpretation. This democratization of astronomical discovery created a rich ecosystem of observation and analysis that extended far beyond traditional academic institutions. Retired engineers applied their technical skills to trajectory calculations, software developers created visualization tools for orbital analysis, and curious individuals with no formal scientific training found ways to contribute to the collective effort to understand our mysterious visitor. The collaborative nature of the 3I Atlas investigation reflected broader trends in modern scientific research, where complex problems increasingly require interdisciplinary cooperation and diverse perspectives. The mystery of 3I Atlas was not something that could be solved by any single individual or institution, but rather demanded the collective intelligence and resources of a global scientific community. As we moved deeper into the summer of 2025, the observational campaign intensified and the stakes seemed to grow with each new piece of data. The upcoming perihelion passage would provide the best opportunities for detailed study, but it would also mark the beginning of 3I Atlas's departure from our neighbourhood. The ephemeral nature of the encounter added urgency to every observation and analysis. Unlike planets or stars, which remain available for study over years or decades, 3I Atlas offered only a brief window of opportunity before returning to the cosmic depths from which it had emerged. This temporal pressure created a unique dynamic in the scientific investigation. Researchers had to balance the need for careful, methodical analysis with the reality that their subject was disappearing even as they studied it. Every day brought new observations and insights, but also represented one day less for future study. The race against time became particularly acute when considering the more exotic interpretations of 3I Atlas's nature. If the object were indeed some form of extraterrestrial technology, then its study might represent humanity's first and perhaps only opportunity to examine such artifacts directly. The implications of potentially missing such an opportunity were profound enough to motivate unprecedented levels of international cooperation and resource allocation. Telescopes typically booked months or years in advance were rapidly rescheduled to focus on 3I Atlas. Funding agencies accelerated review processes for research proposals related to the object's study. Graduate students and postdoctoral researchers found their career trajectories suddenly intersecting with one of the most significant astronomical discoveries of the century. Yet even as the professional astronomical community mobilized its resources around 3I Atlas, the object itself remained frustratingly enigmatic. Each new observation seemed to provide as many new questions as answers, creating a puzzle that grew more complex rather than simpler with accumulated data. The brightness variations observed by multiple telescopes suggested a rotating object with an irregular shape, consistent with natural asteroidal or cometary nuclei. Yet the rotation period appeared unusually stable, and the brightness changes followed patterns that seemed almost too regular for a natural object shaped by random collision and erosion processes. The spectroscopic detections remained maddeningly subtle and ambiguous. Weak signatures of water vapor and simple carbon compounds appeared and disappeared in the data in ways that suggested either a very unusual composition or possibly intermittent activity controlled by processes not yet understood. The trajectory continued to follow its statistically improbable path with mathematical precision, neither deviating toward more random behavior nor displaying obvious signs of artificial correctional control. 3I Atlas seemed to exist in a perfect balance between natural and artificial interpretations, providing just enough evidence to support either hypothesis while offering definitive proof of neither. This ambiguity became one of the most fascinating aspects of the 3I Atlas phenomenon. Here was an object that appeared to have been designed to occupy precisely the liminal space between known categories, challenging our ability to classify and understand it, while avoiding clear resolution in any particular direction. As July gave way to August, the intensity of observation and analysis reached fevered levels. The upcoming Webb observations promised to provide the most detailed chemical analysis of any interstellar object ever attempted. If 3I Atlas harbored secrets about its origin, composition, or nature, the infrared spectroscopic capabilities of humanity's premier space telescope might finally reveal them. The anticipation surrounding the Webb observations reflected broader hopes and anxieties about the 3I Atlas encounter. For some, the prospect of definitive answers offered the possibility of resolving the mystery and returning to more conventional astronomical pursuits. For others, the fear was that definitive answers might close off the extraordinary possibilities that made 3I Atlas so fascinating in the first place. But perhaps most significantly, the Webb observations represented a test of humanity's readiness to confront genuinely ambiguous phenomena that challenge our existing frameworks for understanding the cosmos. How we interpreted and responded to the Webb data would reveal as much about our own psychological and cultural limitations as about the nature of our mysterious visitor. The James Webb Space Telescope finally turned its unprecedented capabilities toward 3I Atlas on August 6, 2025. The observation session lasted several hours and collected spectroscopic data across a wide range of infrared wavelengths, providing the most detailed chemical analysis of any interstellar object ever attempted. When the data processing was complete and the results began to emerge, they revealed a picture that was both familiar and deeply puzzling. 3I Atlas displayed clear evidence of cometary activity, with spectral signatures of water vapor, carbon dioxide, and various organic compounds consistent with the sublimation of ices as the object approached the Sun. Yet the relative abundances of these molecular species were unlike anything seen in comets from our own solar system or in the previous interstellar visitor Borisov. The carbon dioxide signature was extraordinarily strong, dominating the spectrum in ways that suggested either a very unusual formation environment or possibly non-standard processes governing the object's current activity. The carbon dioxide to water ratio was approximately 8:1, far higher than observed in any natural comet and difficult to explain through conventional models of cometary composition and evolution. This chemical anomaly added another piece to the 3I Atlas puzzle, suggesting either exotic formation conditions in its original stellar system or potentially artificial control over outgassing processes. The Webb observations also revealed isotopic signatures that provided clues about the stellar environment where 3I Atlas had formed. The ratios of carbon-12 to carbon-13 were consistent with material formed around an ancient low metallicity star, supporting estimates that the object might be billions of years older than our own solar system. This ancient origin added a profound temporal dimension to the 3I Atlas mystery. Here was an object that potentially predated not only our solar system, but possibly even the galactic environment in which we currently reside. It carried within its structure the chemical fingerprints of stellar processes that had occurred when our galaxy was young, offering a direct physical link to cosmic history extending back toward the very dawn of star formation. Yet even these remarkable chemical revelations failed to resolve the fundamental ambiguity surrounding 3I Atlas's nature. The unusual molecular abundances could indicate exotic natural processes operating in ancient stellar environments, or they might reflect artificial selection and control of observable characteristics designed to maintain ambiguity about the object's true nature. The Webb observations were supplemented by data from the Sphere-X Space Telescope, which conducted extended monitoring of 3I Atlas during the second week of August. Sphere-X detected an extensive carbon dioxide cloud extending hundreds of thousands of kilometers around the object, confirming the Webb's spectroscopic results while adding new puzzles about the mechanisms driving such extensive outgassing. The Sphere-X data showed that the carbon dioxide emission was not uniform around 3 from the Atlas, but instead displayed a complex spatial structure that seemed to vary over time. This variability suggested either complex rotation and surface activity patterns or potentially more exotic processes governing the object's interaction with solar radiation. As these sophisticated observations accumulated, the scientific picture of 3I Atlas became simultaneously clearer and more mysterious. The object was definitely behaving like a comet, releasing gas and dust as it approached the sun and displaying the expected responses to solar heating. Yet every detail of this behavior seemed to contain subtle anomalies that distinguished 3I Atlas from more conventional cometary visitors. The accumulating evidence painted a portrait of an object that was simultaneously familiar and alien, natural yet inexplicable, ancient yet somehow perfectly adapted to the specific conditions of its encounter with our solar system. 3I Atlas seemed to exist in a unique category that challenged the traditional boundaries between known astronomical phenomena. Meanwhile, the theoretical framework developed around the reconnaissance hypothesis continued to evolve and gain sophistication. Dr. Loeb and his collaborators published additional papers exploring the implications of treating 3I Atlas as a potential technological artifact rather than a purely natural object. These theoretical explorations examined questions such as what observational signatures might distinguish artificial objects from natural ones, how advanced civilizations might design reconnaissance probes to avoid detection, and what strategic considerations might govern the timing and trajectory of interstellar survey missions. The reconnaissance hypothesis was not presented as a definitive explanation for 3I Atlas, but rather as a framework for thinking about how we might recognize extraterrestrial technology if it appeared in our solar system. The researchers emphasized that maintaining multiple working hypotheses was essential when dealing with phenomena that challenged existing paradigms. This theoretical work had implications extending far beyond the specific case of 3I Atlas. It represented part of a broader evolution in how the scientific community was beginning to think about the search for extraterrestrial intelligence and the possibility of contact with advanced civilizations. Rather than limiting such searches to deliberate communication attempts like radio signals, researchers were beginning to consider the full range of ways that extraterrestrial intelligence might manifest itself in the observable universe. Archaeological artifacts, abandoned technology, active probes, and even deliberately ambiguous objects designed to test the responses of emerging civilizations all became part of the expanding search strategy. This broader perspective transformed 3Y Atlas from an isolated anomaly into a potential harbinger of a new era in astrobiology and SETI research. Whether the object ultimately proved to be natural or artificial, its study was advancing our understanding of how to recognize and analyze phenomena that might indicate the presence of intelligence beyond Earth. As August progressed and 3I Atlas continued its approach toward the inner solar system, public fascination with the object reached extraordinary levels. Social media platforms buzzed with analysis and speculation, amateur astronomers shared observations and theories, and science communication channels struggled to keep pace with the flood of new developments and interpretations. The democratization of information about 3I Atlas created a global conversation about cosmic possibilities that transcended traditional boundaries between professional and amateur astronomy. Retired aerospace engineers analyzed trajectory data, software developers created visualization tools, students designed citizen science projects, and curious individuals with no formal scientific training found ways to contribute meaningful insights to the collective investigation. This unprecedented level of public engagement with an astronomical discovery reflected broader cultural shifts in how science operates in the modern world. The 3I Atlas story unfolded in real time before a global audience that was simultaneously consuming, analyzing, and contributing to the scientific understanding of our mysterious visitor. The collaborative nature of the investigation also highlighted the international character of modern astronomical research. Telescopes in Chile provided initial detection, observatories in Hawaii contributed detailed observations, space telescopes operated by American and European agencies collected crucial data, and researchers from universities around the world contributed theoretical analysis and interpretation. This global scientific cooperation occurred against a backdrop of increasing geopolitical tension and international rivalry, demonstrating the unique ability of astronomical discovery to transcend earthly divisions and unite humanity around shared questions about our place in the cosmos. Yet even as the scientific investigation proceeded with unprecedented sophistication and international cooperation, fundamental questions about 3I Atlas remained frustratingly unanswered. The object continued to occupy that liminal space between categories, providing enough evidence to support multiple interpretations while offering definitive proof of none. As we moved deeper into August and 3I Atlas approached its date with destiny in the inner solar system, the stakes of understanding its true nature seemed to grow with each passing day. The upcoming perihelion passage would provide the final opportunities for detailed study before the object began its journey back to the cosmic depths. The ephemeral nature of the encounter added poignancy to every observation and analysis. Soon, 3I Atlas would be gone, leaving behind only the data we had managed to collect and the memories of a few months when humanity glimpsed something that might have been extraordinary, or might have been perfectly ordinary, or might have been something altogether beyond our current ability to comprehend. The late summer of 2025 brought with it a growing sense of anticipation and urgency as 3I Atlas continued its relentless approach toward the inner solar system. The object's trajectory would soon carry it past Mars, offering what might be humanity's closest look at our mysterious visitor before it disappeared behind the sun during its perihelion passage. The Mars encounter, scheduled for early October, sparked intense interest among planetary scientists and mission planners. Several spacecraft currently in orbit around the red planet possessed imaging capabilities that could potentially capture unprecedented close-up views of 3Y Atlas as it swept past at a distance of approximately 29 million kilometers. The Mars Reconnaissance Orbiter, with its powerful HIRAS camera system, represented the most promising opportunity for detailed imaging. HIRAS had previously demonstrated its ability to photograph objects as small as individual spacecraft from orbit, and the 3I Atlas flyby would bring the mysterious object within range of this remarkable instrument. Mission planners began the complex process of calculating optimal observation geometries and coordinating spacecraft operations to maximize the scientific return from this fleeting opportunity. The Mars encounter would last only a few hours, during which time 3I Atlas would transition from approach to departure, offering a unique chance to study the object from multiple angles and potentially detect surface features or activity patterns invisible from Earth-based observations. But the Mars encounter also raised more speculative possibilities that captured public imagination in ways that traditional astronomical observations rarely achieve. If 3I Atlas were indeed some form of reconnaissance probe, as the more exotic hypotheses suggested, then its close approach to Mars might represent a detailed survey mission designed to gather comprehensive data about the red planet. The timing seemed almost too convenient to be coincidental. Mars had never been more interesting to human civilization than it was in the mid-2020s. Multiple nations were operating sophisticated rovers on the Martian surface. Orbital missions were conducting detailed geological and atmospheric surveys, and serious planning was underway for eventual human missions to the planet. From the perspective of an extraterrestrial intelligence, Mars in 2025 would represent a fascinating case study in planetary exploration and potential terraforming. The planet harbored clear evidence of ancient habitable conditions, possible signs of past or present microbial life, and an increasingly complex array of human technological artifacts scattered across its surface and orbital environment. If 3I Atlas were indeed conducting reconnaissance, the Mars flyby would provide an ideal opportunity to assess both the planet's natural characteristics and the extent of human technological presence. The probe could potentially analyze atmospheric composition, study surface geology, photograph human installations, and evaluate our technological capabilities, all while maintaining the appearance of a natural flyby trajectory. These speculative possibilities transform the Mars encounter from a purely scientific opportunity into something approaching a first contact scenario. If 3I Atlas were artificial, humanity might be witnessing its first detailed assessment by an extraterrestrial intelligence, a cosmic inspection that would determine how we were perceived by minds from other worlds. The psychological impact of this possibility extended far beyond the scientific community. Social media platforms buzzed with speculation about what 3I Atlas might be learning about us, how it might be interpreting human civilization, and what its eventual report might contain if transmitted to distant controllers. These discussions revealed something profound about human nature and our relationship with the possibility of cosmic contact. The 3I Atlas encounter was forcing us to see ourselves from an external perspective, to imagine how our civilization might appear to intelligences that had mastered interstellar travel and possessed technologies beyond our current understanding. The self-reflection prompted by 3I Atlas was perhaps as significant as any scientific discoveries that might emerge from its study. We were confronting fundamental questions about our place in the cosmic order, our readiness for contact with advanced civilizations, and our worthiness as representatives of intelligence and consciousness in the universe. Meanwhile, preparations continued for the sophisticated observational campaigns that would accompany 3Y Atlas through its final approach to the Sun. Ground-based telescopes around the world coordinated their efforts to maintain continuous coverage as the object transitioned from the evening to the morning sky, while space-based observatories prepared for what might be their final opportunities to study our mysterious visitor. The coordination required for these observations represented one of the most complex international scientific collaborations ever undertaken for the study of a single astronomical object. Telescope time at the world's premier observatories was redirected from long-planned research programs to focus on 3I Atlas, reflecting the scientific community's recognition that this encounter might represent a once-in-a-lifetime opportunity for discovery. The logistical challenges were immense. 3I Atlas was moving rapidly across the sky, requiring constant updates to telescope pointing and tracking systems. Its brightness was changing as it approached the Sun, necessitating adjustments to exposure times and detector configurations. Its position relative to background stars was shifting continuously, complicating efforts to maintain accurate photometry and spectroscopy. Yet despite these challenges, the observational campaign proceeded with remarkable precision and coordination. Data flowed from telescopes around the globe to central processing facilities where teams of researchers worked around the clock to extract meaningful scientific results from the flood of observations. The dedication and collaboration displayed by the international astronomical community during the 3Y Atlas encounter reflected the profound significance that researchers attached to this opportunity. Whether the object ultimately proved to be natural or artificial, its study was advancing our understanding of interstellar visitors, cometary physics, and the techniques required for detecting and analyzing unusual phenomena in our solar system. As September arrived and 3I Atlas continued its approach, the object began to display increased activity that provided new insights into its composition and behavior. The coma surrounding the nucleus grew more prominent and complex, developing structures and asymmetries that suggested either irregular outgassing from the surface or possibly more exotic processes governing the release and distribution of material. Spectroscopic observations revealed evolving molecular signatures as different volatile compounds began to sublimate under increasing solar heating. The dominant carbon dioxide emission continued to distinguish 3I Atlas from more typical comets, but new spectral features appeared that provided additional clues about the object's chemical composition. The detection of carbonyl sulfide, a relatively rare molecule in solar system comets, added another piece to the chemical puzzle surrounding 3I Atlas. This compound typically forms under specific temperature and pressure conditions that might indicate unusual formation environments or processing during the object's interstellar journey. The isotopic signatures revealed by high-resolution spectroscopy continue to support the hypothesis that 3I Atlas had formed around an ancient, low metallicity star. The chemical fingerprints locked within its structure told a story of stellar nucleosynthesis processes that had occurred billions of years ago, when the galaxy was young and the abundance of heavy elements was much lower than in our current stellar neighborhood. These ancient chemical signatures provided a direct physical link to the early history of our galaxy, offering insights into stellar and planetary formation processes that had operated under very different conditions than those that created our own solar system. 3I Atlas was not just an interstellar visitor but a time traveler, carrying within its structure the preserved record of cosmic processes that had shaped our galaxy long before Earth existed. Yet, even as these remarkable scientific insights accumulated, the fundamental ambiguity surrounding 3I Atlas's nature persisted. Each new observation seemed to reveal characteristics that were simultaneously fascinating from a natural science perspective and consistent with more exotic interpretations involving artificial origins or technological control. The increased activity observed as 3I Atlas approached the inner solar system could represent normal cometary behavior responding to solar heating, or it might indicate activation of technological systems as the object prepared for its detailed survey of our planetary neighborhood. The evolving spectral signatures could reflect natural sublimation processes, or they might result from controlled release of materials designed to maintain the appearance of cometary behavior. This persistent ambiguity became one of the most remarkable aspects of the 3I Atlas phenomenon. The object seemed to exist in a perfect balance between interpretations, providing sufficient evidence to support multiple hypotheses while offering definitive proof of none. It was as if 3I Atlas had been specifically designed to occupy this liminal space between categories, challenging our ability to classify and understand it. The philosophical implications of this ambiguity extended far beyond the specific case of 3I Atlas. The object was forcing us to confront the limitations of our observational capabilities and analytical frameworks when dealing with the phenomena that might represent genuinely novel categories of cosmic objects. How do we distinguish between natural and artificial when dealing with technologies that might be millions of years more advanced than our own? What observational signatures would reliably indicate intelligence when that intelligence might deliberately choose to remain ambiguous? How do we maintain appropriate scientific skepticism while remaining open to possibilities that could fundamentally transform our understanding of our place in the universe? These questions touched on some of the deepest epistemological challenges in modern science. The 3I Atlas encounter was revealing the extent to which our scientific methodologies were calibrated for dealing with natural phenomena and might be inadequate for recognizing and analyzing artificial objects created by intelligences far more advanced than ourselves. The search for extraterrestrial intelligence had traditionally focused on detecting deliberate communication attempts or obvious technological signatures like massive engineering projects. But 3-Eye Atlas suggested that actual contact might be far more subtle and ambiguous, requiring new approaches to observation and analysis that could recognize intelligence even when it chose to remain partially hidden. As September progressed, the intensity of public interest in 3-Eye Atlas reached extraordinary levels. The approaching Mars encounter and upcoming perihelion passage were generating widespread media coverage that ranged from serious scientific analysis to wild speculation about alien visitation and potential first contact scenarios. Social media platforms became battlegrounds for competing interpretations of the accumulating evidence. Supporters of natural explanations pointed to the spectroscopic conformation of cometary molecules and the expected response to solar heating. Advocates for artificial hypotheses emphasized the statistical improbability of the trajectory and the anomalous chemical signatures revealed by advanced spectroscopy. The democratization of information about 3-Eye Atlas created a global conversation that transcended traditional boundaries between expert and amateur analysis. Retired aerospace engineers contributed sophisticated trajectory calculations, amateur astronomers provided valuable observational data, and curious individuals with no formal scientific training found ways to participate meaningfully in the collective investigation. This unprecedented level of public engagement with an astronomical discovery reflected broader cultural shifts towards citizen science and collaborative research. The 3-Eye Atlas phenomenon demonstrated how modern communication technologies could enable truly global participation in scientific inquiry, creating opportunities for insights and perspectives that might be missed by traditional academic approaches. Yet the flood of information and analysis also created challenges for distinguishing reliable observations from speculation and wishful thinking. The scientific method depends upon careful validation and peer review of results, processes that can be overwhelmed when dealing with rapidly evolving phenomena that capture widespread public attention. The 3-Eye Atlas story became a case study in how science operates in the modern information environment, where traditional gatekeeping mechanisms must adapt to accommodate both genuine citizen science contributions and the inevitable noise that accompanies any topic of intense public interest. Meanwhile, preparations intensified for what promised to be the climactic phase of the 3-Eye Atlas encounter. The October 3rd Mars flyby would provide unprecedented imaging opportunities, while the October 30th perihelion passage would mark the object's closest approach to the Sun and its maximum activity level. But here the story took another intriguing turn. The geometry of 3-Eye Atlas's orbit meant that its perihelion passage would occur when the object was positioned on the opposite side of the Sun from Earth, making detailed observation impossible from our planet or most space-based observatories. This cosmic eclipse would last for several weeks, during which time 3-Eye Atlas would be hidden behind the blazing disk of our star, invisible to telescopes and completely cut off from direct observation. The timing seemed almost too convenient for an object that might prefer to avoid detailed scrutiny during its most active and potentially revealing phase. If 3-Eye Atlas were indeed some form of reconnaissance probe, the period of solar eclipse would provide ideal cover for activities that its creators might wish to keep hidden from terrestrial observers. The object could potentially deploy smaller survey craft, conduct detailed planetary observations, or even execute trajectory corrections without fear of detection from Earth. The hidden perihelion passage became a focal point for the more speculative theories surrounding 3-Eye Atlas. Conspiracy theorists suggested that the object would use this period of invisibility to conduct clandestine operations in the inner solar system, while more mainstream researchers acknowledged that the observational gap would leave crucial questions about the object's behavior permanently unanswered. The timing of the solar eclipse also raised practical questions about spacecraft missions that might be able to observe 3-Eye Atlas during its hidden passage. The Parker Solar Probe, humanity's fastest spacecraft and the only artificial object capable of approaching the Sun's immediate vicinity, would be relatively close to 3-Eye Atlas during the perihelion period. Mission planners began exploring whether Parker Solar Probe's instruments might be able to detect or photograph 3-Eye Atlas during the solar eclipse, potentially providing the only direct observations of the object's behavior during its most active phase. However, the technical challenges were formidable, requiring precise coordination of spacecraft operations and potentially risky adjustments to the probe's trajectory and instrument pointing. The possibility of Parker Solar Probe observations added another layer of anticipation to the 3I Atlas encounter. If successful, these observations might provide crucial data about the object's behavior during perihelion, potentially resolving some of the lingering questions about its nature and origins. But even if Parker Solar Probe managed to observe 3I Atlas during the solar eclipse, the results would likely be ambiguous enough to support multiple interpretations. The spacecraft's instruments were designed to study the solar environment rather than distant objects, and the challenging observational conditions would limit the quality and detail of any data that might be obtained. As early October arrived, the Mars encounter began to dominate discussions about 3I Atlas. The approaching flyby represented humanity's best opportunity for close-up observation of the mysterious object, offering the potential to resolve at least some of the questions that had accumulated during months of long-distance study. The Mars Reconnaissance Orbiter's high-rise camera was the primary hope for detailed imaging during the encounter. This remarkable instrument had previously demonstrated its ability to photograph objects as small as individual spacecraft from Martian orbit, and the 3I Atlas flyby would bring the object within range of HIRIS's unprecedented resolution capabilities. If 3I Atlas possessed surface features, structural details, or activity patterns invisible from Earth, the HIRIS observations might finally reveal them. The camera could potentially detect artificial structures, unusual surface compositions, or asymmetric outgassing patterns that might distinguish technological artifacts from natural objects. The anticipation surrounding the HIRIS observations reflected broader hopes that the Mars encounter might finally provide definitive answers about 3Y Atlas's nature. After months of ambiguous data and competing interpretations, the prospect of high-resolution imaging offered the possibility of clarity and resolution. Yet even as expectations built around the Mars observations, researchers cautioned that the results might be less definitive than hoped. 3I Atlas would be moving rapidly during the encounter, limiting the exposure time available for detailed photography. The object's distance from Mars, while close by astronomical standards, would still be measured in millions of kilometers, restricting the level of detail that even HIRIS could resolve. More fundamentally, the challenge of distinguishing natural from artificial origins might persist even with high-resolution imaging. Advanced extraterrestrial technology might be indistinguishable from natural phenomena when observed at the resolution limits of our current instruments. Alternatively, natural objects could display features that might appear artificial when viewed through the lens of human technological expectations. The Mars encounter thus represented both an opportunity for breakthrough discovery and a potential lesson in the limitations of observational astronomy when dealing with genuinely ambiguous phenomena. Regardless of what the HIRIS observations revealed, they would contribute to our understanding of both 3I Atlas specifically and the broader challenges of studying unusual objects in our solar system. As October 3rd approached, the global astronomical community focused its attention on Mars with unprecedented intensity. The flyby would last only a few hours, but those hours might contain observations that would be analysed and debated for decades to come. The Mars Reconnaissance Orbiter began its observation sequence in the early hours of October 3rd, with HIRIS trained on the predicted position of 3I Atlas as it approached the red planet. The camera captured a series of images as the object swept past, documenting its appearance and behaviour during humanity's closest encounter with our mysterious visitor. When the images were processed and analysed, they revealed a picture that was both fascinating and frustratingly ambiguous. 3I Atlas appeared as a roughly spherical object surrounded by a clearly visible coma of gas and dust, confirming its cometary nature while providing the first direct visual evidence of its nucleus structure. The HIRIS images showed what appeared to be an irregular surface with variations in brightness that could indicate either compositional differences or topographical features. The coma surrounding the nucleus displayed a complex structure with asymmetries and streamers that suggested active outgassing from specific regions of the surface. Yet even these remarkable high-resolution observations failed to resolve the fundamental questions about 3Y Atlas's nature. The surface features visible in the HIRIS images could represent natural geological processes or potentially artificial structures beyond the resolution limits of the camera. The outgassing patterns could indicate normal cometary activity or possibly controlled release of materials designed to maintain the appearance of natural behavior. The Mars encounter observations thus added another layer to the 3I Atlas mystery rather than providing definitive answers. The object continued to occupy that liminal space between categories, displaying characteristics that were consistent with both natural and artificial interpretations, while offering conclusive evidence for neither. The ambiguity of the Mars observations sparked intense debate within the scientific community and broader public discussions about the nature of evidence and the challenges of interpreting observations at the limits of our technological capabilities. Some researchers argued that the high-rise images confirmed 3I Atlas as a natural comet, while others maintained that the observations were consistent with more exotic explanations involving technological origins. This ongoing ambiguity reflected deeper philosophical questions about the nature of scientific knowledge and the criteria for distinguishing between different types of explanations. How much evidence is required to support extraordinary claims? What level of proof should be demanded before accepting interpretations that challenge existing paradigms? How do we balance appropriate skepticism with openness to genuinely novel phenomena? These epistemological challenges became as significant as the observational questions surrounding 3I Atlas itself. The object was forcing the scientific community to confront fundamental assumptions about methodology, evidence, and the process of discovery in ways that extended far beyond the specific case at hand. As 3I Atlas continued past Mars and began its final approach toward perihelion, the observational opportunities from Earth-based telescopes began to diminish rapidly. The object's position relative to the Sun made detailed study increasingly difficult, and soon it would disappear entirely behind our star's brilliant disk. The approaching solar eclipse marked the beginning of what would be the most mysterious phase of the 3I Atlas encounter. For several weeks, our visitor would remain completely hidden from terrestrial observation, free to behave in whatever manner its nature dictated without fear of detection or analysis. If 3I Atlas were indeed a natural comet, the solar eclipse would simply represent a temporary observational inconvenience. The object would continue its predictable orbital motion, reach perihelion according to the calculated trajectory, and eventually emerge on the other side of the Sun, displaying whatever changes had occurred during its closest approach to our star. But if the more exotic interpretations were correct, the period of solar eclipse might witness activities that would forever remain hidden from human observation. An artificial object could potentially deploy survey craft, execute trajectory corrections, or conduct detailed studies of the inner solar system, while safely concealed behind the Sun's overwhelming brightness. The hidden perihelion passage thus became a source of both scientific frustration and speculative fascination. Researchers acknowledged that crucial questions about 3I Atlas's behavior during its most active phase might never be answered, while more imaginative observers wondered what secrets might be unfolding in the hidden space behind our star. The approaching eclipse also heightened awareness of the ephemeral nature of the entire 3I Atlas encounter. Soon, our mysterious visitor would begin its journey back to the cosmic depths, carrying with it whatever secrets it had gathered during its passage through our solar system. The brief window of opportunity for study and discovery was rapidly closing, adding urgency to every remaining observation and analysis. As October progressed and 3I Atlas approached its date with solar eclipse, the global conversation about our cosmic visitor reached a crescendo of intensity and speculation. Media coverage ranged from sober scientific analysis to wild conspiracy theories about alien reconnaissance and potential first contact scenarios. The 3I Atlas phenomenon had transcended its origins as an astronomical curiosity to become a cultural touchstone for broader questions about humanity's place in the universe, our readiness for contact with advanced civilizations, and the nature of intelligence and consciousness on cosmic scales. Educational institutions found themselves grappling with how to present the 3I Atlas story to students and the public. How do you teach critical thinking and scientific methodology while acknowledging that our universe might contain phenomena that challenge our most fundamental assumptions? how do you balance appropriate skepticism with genuine openness to extraordinary possibilities? The 3i Atlas encounter became a masterclass in the philosophy of science, demonstrating both the power and the limitations of our observational and analytical capabilities when confronted with genuinely ambiguous phenomena. It highlighted the importance of maintaining multiple working hypotheses, the challenges of interpreting data at the limits of instrumental resolution, and the role of cultural and psychological factors in shaping our responses to the unknown. As the solar eclipse approached and 3i Atlas prepared to disappear behind our star, the scientific community and interested public alike were left to contemplate what had been learned and what might forever remain unknown about our enigmatic visitor. The encounter had raised more questions than it answered, opened more possibilities than it closed, and challenged more assumptions than it confirmed. Whether 3i Atlas ultimately proved to be a natural comet from ancient stellar environments, or something far more extraordinary, its passage through our solar system had already transformed our understanding of what it means to encounter the genuinely unknown in an age of advanced scientific instrumentation and global communication. The object was about to vanish behind the sun, beginning its hidden journey through the inner solar system where it would remain invisible to human observation for crucial weeks during its most active phase. When it eventually emerged on the other side of our star, 3i Atlas might be unchanged from its hidden passage, or it might carry evidence of activities and transformations that would forever alter our understanding of visitors from the stars. The approaching eclipse marked not just the end of direct observation, but the beginning of a period of suspense and speculation that would test our patience, our imagination, and our ability to live with profound uncertainty about one of the most intriguing phenomena ever to grace our skies. As 3i Atlas began its final approach toward the Sun in mid-October, the last ground-based observations captured images of an object that seemed to be awakening from its interstellar slumber. The coma surrounding the nucleus had grown more prominent and complex, developing intricate structures that suggested either sophisticated outgassing patterns or possibly more exotic processes governing the release and distribution of material into space. Spectroscopic observations during this final visible phase revealed molecular signatures that continue to puzzle researchers. The dominant carbon dioxide emission remained far stronger than expected for natural comets, while new spectral features appeared that suggested the activation of previously dormant chemical processes within the object's interior. The detection of hydrogen sulfide, ammonia, and various organic compounds provided additional pieces to the chemical puzzle surrounding 3i Atlas. These molecules typically sublimate at different temperatures, and their simultaneous appearance suggested either a very heterogeneous composition or possibly controlled release mechanisms that differed from normal cometary behavior. The temperature dependence of molecular emissions from 3i Atlas also displayed anomalies that challenged conventional understanding of cometary physics. Some compounds appeared to be outgassing at solar distances where they should remain frozen, while others seemed surprisingly stable despite approaching temperatures that should trigger vigorous sublimation. These thermal anomalies suggested either unusual physical properties of the nucleus material or possibly artificial control over outgassing processes. Natural explanations might involve complex surface chemistry or subsurface layering that created unexpected thermal responses, while more exotic interpretations could invoke technological regulation of observable emissions. The final Earth-based observations also revealed subtle changes in 3i Atlas's rotation and brightness patterns that added another layer to the accumulating mysteries. The object appeared to be rotating more slowly than expected for a natural body of its estimated size and shape, while brightness variations suggested either unusual surface properties or possibly changes in activity patterns as it approached perihelion. These rotational anomalies became particularly intriguing when analysed in the context of the object's trajectory and timing. If 3i Atlas were indeed some form of reconnaissance probe, the observed rotation rate might represent optimal conditions for conducting systematic surveys of the solar system environment. A slowly rotating object would be able to maintain stable pointing toward targets of interest for extended periods, enabling detailed observations that might be impossible with the rapid tumbling typical of natural asteroids and comets. The timing of brightness variations might correspond to the activation of different observational systems or the execution of specific survey protocols. Yet these same characteristics could also result from perfectly natural processes involving the object's internal structure, surface composition, or response to solar heating. The challenge of distinguishing between natural and artificial explanations persisted even as the quality and detail of observations continued to improve. As October 20th arrived and 3I Atlas prepared to disappear behind the sun, the astronomical community found itself in the peculiar position of losing its subject of study, just as that subject was entering its most interesting and potentially revealing phase. The approaching solar eclipse would cut off all direct observation precisely when 3I Atlas should be displaying its maximum activity and most dramatic responses to solar heating. This timing seemed almost designed to maximize mystery and minimize resolution. Natural comets typically become most active and spectacular during their close approach to the sun, when solar radiation drives vigorous outgassing that creates magnificent tails and comas visible across the solar system. 3I Atlas would experience all of these processes while safely hidden behind our star's overwhelming brightness. The hidden perihelion passage sparked intense speculation about what might be occurring beyond the reach of human observation. If 3I Atlas were indeed a natural comet, it would be undergoing the same physical processes that had been observed in countless other comets throughout human history. Solar heating would drive the sublimation of volatile compounds, creating expanding clouds of gas and dust that would be swept away by solar wind and radiation pressure. But if the more exotic interpretations were correct, the period of solar eclipse might witness activities that would justify all the speculation and theoretical analysis that had surrounded the object since its discovery. An advanced reconnaissance probe might use this hidden passage to conduct detailed surveys of the inner solar system, deploy smaller survey craft, or execute trajectory corrections that would be impossible to accomplish under direct terrestrial observation. The possibility of hidden activities during the solar eclipse became a focal point for the more speculative theories surrounding 3I Atlas. Online communities devoted to UFO phenomena and extraterrestrial contact seized upon the convenient timing of the eclipse as evidence supporting artificial origins for the mysterious object. These discussions reflected broader cultural fascination with the possibility of alien visitation and the ways that such contact might occur. The 3I Atlas encounter seemed to embody many of the characteristics that UFO researchers had long predicted for genuine extraterrestrial contact: ambiguous evidence that challenged conventional interpretation, timing that seemed too convenient to be coincidental, and official responses that maintained careful skepticism while avoiding definitive dismissal. The cultural response to 3I Atlas demonstrated how astronomical discoveries could serve as Rorschach tests for deeper human anxieties and aspirations about our place in the universe. The same observational evidence was interpreted through radically different frameworks, depending on the observer's prior beliefs about the likelihood of extraterrestrial intelligence and the nature of potential contact scenarios. Meanwhile, the scientific community grappled with the practical and philosophical challenges of studying an object that was about to vanish from observation during its most potentially revealing phase. Researchers had to balance the legitimate excitement surrounding 3I Atlas with the methodological requirements of rigorous scientific investigation. The approaching eclipse highlighted fundamental limitations in our ability to study transient phenomena in the solar system. Unlike planets and moons, which remain available for observation over years and decades, visiting objects like 3I Atlas offered only brief windows of opportunity that might not align with optimal observational conditions. These limitations were particularly frustrating when dealing with objects that might represent unprecedented opportunities for discovery. If 3I Atlas were indeed humanity's first encounter with extraterrestrial technology, the inability to observe its behavior during perihelion might represent a permanent loss of crucial evidence about the nature and capabilities of advanced alien civilizations. The potential for irreversible loss of scientific opportunity added urgency to discussions about future preparedness for similar encounters. How could humanity develop the observational infrastructure and analytical capabilities needed to study unusual objects more effectively? What investments in technology and international cooperation would be required to ensure that future interstellar visitors could be studied with the thoroughness that they deserved? These questions extended beyond the specific case of 3YR Atlas to encompass broader issues about scientific priorities and resource allocation in an age of potentially transformative discoveries. The object had demonstrated how quickly unusual phenomena could appear and disappear, challenging traditional approaches to scientific planning that assumed stable subjects available for extended study. As October 25th arrived and 3I Atlas began to disappear behind the solar disk, the last direct observations captured images of an object that seemed to be reaching peak activity. The coma had expanded to its maximum size and complexity, displaying intricate structures and asymmetries that suggested vigorous outgassing from multiple regions of the nucleus. Spectroscopic observations during these final moments revealed molecular signatures at their strongest levels, confirming that 3I Atlas was indeed responding to solar heating in ways generally consistent with cometary behavior. Yet even these confirmatory observations contained subtle anomalies that maintained the ambiguity surrounding the object's ultimate nature. The final images showed 3I Atlas as a bright, fuzzy object surrounded by an expanding cloud of gas and dust that caught and reflected sunlight in ways that created a surprisingly beautiful and almost ethereal appearance. Whatever else it might be, 3I Atlas had proven itself capable of displaying the spectacular beauty that had made comets objects of wonder and inspiration throughout human history. As the object vanished behind the sun and direct observation became impossible, the scientific community settled in for a period of analysis and speculation that would last until 3I Atlas emerged on the other side of our star in early December. The weeks of solar eclipse would provide an opportunity to thoroughly analyze all the accumulated observational data while anticipating what new revelations might await when the object became visible again. The hidden period also offered a chance for theoretical work to catch up with observational discoveries. Researchers could develop more sophisticated models of 3RA behavior, explore the implications of various interpretations of its nature, and prepare for the observational campaigns that would accompany its emergence from behind the sun. During the solar eclipse, the only potential sources of information about 3 Atlas would be the handful of spacecraft that might be positioned to observe the object during its hidden passage. The Parker Solar Probe, humanity's fastest spacecraft and the only artificial object capable of approaching the sun's immediate vicinity, represented the most promising possibility for observations during perihelion. Mission planners had been working to determine whether Parker Solar Probe's instruments might be able to detect or photograph 3I Atlas during the solar eclipse. The technical challenges were formidable, requiring precise coordination of spacecraft operations and potentially risky adjustments to the probe's trajectory and instrument pointing. The possibility of Parker Solar Probe observations added an element of hope to the otherwise frustrating period of solar eclipse. If successful, these observations might provide the only direct evidence of 3I Atlas's behavior during its closest approach to the Sun, potentially resolving some of the lingering questions about its nature and origins. But even if Parker Solar Probe managed to observe 3I Atlas during the hidden passage, the results would likely be limited by the spacecraft's distance from the object and the challenging observational conditions near the Sun. The probe's instruments were designed primarily to study the solar environment rather than distant objects, and any data obtained would probably be ambiguous enough to support multiple interpretations. As November arrived, and 3I Atlas remained hidden behind the Sun, public interest in the object shifted from direct observation to speculation about what might be occurring beyond the reach of human detection. Social media platforms buzzed with theories ranging from the scientifically plausible to the utterly fantastic, reflecting the broad spectrum of human responses to genuinely mysterious phenomena. The period of solar eclipse became a kind of enforced meditation on the limits of knowledge and the nature of scientific discovery. Here was an object that had captured global attention and sparked intense investigation, yet its most crucial behaviors were occurring beyond the reach of our most advanced observational capabilities. This enforced ignorance highlighted fundamental philosophical questions about the nature of reality and our ability to understand it. How much of the universe remains hidden from us not because it is fundamentally unknowable, but simply because we lack the technological capabilities or observational positions needed to detect and study it. The 3-Atlas eclipse period served as a reminder that our understanding of the cosmos is necessarily incomplete, and that the most significant discoveries might be occurring constantly in regions of space and time that remain invisible to our current instruments and techniques. Meanwhile, analysis of the accumulated 3I-Atlas data continued with unprecedented intensity. Researchers around the world collaborated to extract every possible insight from the months of observations that had been obtained before the object disappeared behind the Sun. Sophisticated computer models were developed to interpret the spectroscopic data. Trajectory analysis was refined to incredible precision, and theoretical frameworks were expanded to accommodate the unusual characteristics that had been observed. These analytical efforts revealed new layers of complexity in the 3I-Atlas phenomenon that had not been apparent during the initial observational campaigns. The chemical signatures showed subtle variations over time that might indicate evolving internal processes or changing environmental conditions. The trajectory data revealed minute perturbations that could represent either natural gravitational influences or possibly non-gravitational forces of unknown origin. The accumulated brightness measurements displayed patterns that suggested either complex rotational dynamics or periodic changes in surface activity that followed no obvious natural cycles. Taken together, the complete dataset painted a picture of an object that was simultaneously more complex and more mysterious than had been appreciated during the excitement of real-time observation. The detailed analysis also revealed the remarkable international collaboration that had characterized the 3I-Atlas investigation from its earliest days. Data from telescopes in Chile, Hawaii, Australia, South Africa, and numerous other locations had been combined to create a comprehensive observational record that no single institution could have achieved independently. This collaborative approach had enabled insights that might have been impossible through individual efforts, demonstrating the power of modern scientific cooperation when dealing with phenomena that require global coordination and diverse expertise. The 3I-Atlas encounter had become a model for how the international scientific community could respond to potentially transformative discoveries. Yet even as the collaborative analysis proceeded, fundamental questions about 3I-Atlas remained frustratingly unanswered. The accumulated data supported multiple interpretations, ranging from conventional cometary behavior with unusual characteristics to exotic scenarios involving extraterrestrial technology or previously unknown natural phenomena. The persistent ambiguity reflected both the limitations of current observational techniques and the possibility that 3I-Atlas represented something genuinely novel that challenged existing frameworks for understanding cosmic objects. The object seemed to exist in a unique category that bridged familiar and unfamiliar characteristics in ways that defied easy classification. As November progressed and the anticipated emergence of 3I-Atlas from behind the Sun drew closer, expectations began to build around what new insights might be gained from renewed observation. The object would have spent several weeks hidden behind the Sun during its most active phase, and its appearance when it became visible again might reveal crucial information about what had occurred during the eclipse period. If 3I-Atlas were indeed a natural comet, its post-perihelion appearance should display the expected consequences of close solar approach: enhanced outgassing, possible fragmentation or structural changes, and modified surface properties resulting from intense solar heating. The object might appear brighter and more active, with an expanded coma and possibly visible tail structures created by solar wind interactions. But if the more exotic interpretations were correct, the post-eclipse appearance might reveal evidence of activities that had occurred during the hidden passage. Changes in trajectory, modifications to surface properties, or alterations in outgassing patterns might indicate artificial influences or technological interventions that would be difficult to explain through natural processes alone. The anticipation surrounding 3I-Atlas's emergence from solar eclipse reflected broader hopes and anxieties about what the complete encounter might ultimately reveal. Would the object prove to be an interesting but ultimately conventional interstellar comet, adding to our understanding of natural processes in other stellar systems? Or would it turn out to represent something far more extraordinary, that would transform our understanding of intelligence and technology on cosmic scales. These questions touched on some of the deepest aspirations and fears surrounding the search for extraterrestrial intelligence. The possibility of contact with advanced alien civilizations offered the potential for unprecedented scientific and philosophical advancement, but also raised concerns about humanity's readiness for such contact and our ability to respond appropriately to intelligences that might be vastly superior to our own. The 3I Atlas encounter was forcing consideration of these profound questions in ways that purely theoretical discussions of extraterrestrial intelligence had never achieved. It was a specific observable phenomenon that demanded concrete responses and practical decisions, rather than abstract speculation about hypothetical scenarios. As December approached and 3I Atlas prepared to emerge from behind the sun, telescopes around the world were positioned and prepared for what might be the final phase of one of the most intriguing astronomical encounters in human history. The object would soon reappear in the morning sky, potentially transformed by its hidden passage through the inner solar system and ready to reveal whatever secrets it had been keeping during its solar eclipse. The upcoming emergence observations would provide humanity's last opportunity for detailed study of 3Y Atlas before it began its journey back to the cosmic depths. The object's orbital trajectory would carry it steadily away from the Sun and Earth, gradually dimming until it became too faint for even our most powerful telescopes to detect. This ephemeral quality added poignancy to the approaching observations. Whatever 3I Atlas had to reveal about its nature, origins, and activities would need to be discovered during the brief window of visibility that remained before it vanished forever into the interstellar void. The transient nature of the encounter served as a reminder of how rare and precious such opportunities for cosmic discovery could be. Interstellar visitors like 3Y Atlas appeared unpredictably and offered only brief chances for study before returning to the vast emptiness between stars. Each such encounter represented a unique window into cosmic processes and possibilities that might not be repeated for decades or centuries. As the first days of December arrived, and astronomers began scanning the morning sky for signs of 3Y Atlas's return, the global scientific community held its collective breath in anticipation of what might be revealed. The object had been hidden for over a month during what should have been its most active and revealing phase. Its reappearance would provide the first direct evidence of how it had been affected by its close encounter with our star. The emergence observations began on December 3rd, when telescopes in Chile first detected 3Y Atlas as a faint point of light in the constellation Virgo. Initial brightness measurements suggested that the object had indeed been affected by its solar passage, appearing somewhat brighter than predicted based on its pre-eclipse behavior. Spectroscopic observations during the first few days of renewed visibility revealed molecular signatures that confirmed 3I Atlas was still actively outgassing, with carbon dioxide emissions remaining dominant while water vapor and other volatiles appeared at levels consistent with continued cometary activity. The object seemed to have survived its solar encounter and emerged in a state generally consistent with expectations for a natural comet. Yet, even these apparently confirmatory observations contained subtle details that maintained the mystery surrounding 3Y Atlas's ultimate nature. The brightening was more pronounced than typical models predicted for natural comets, while the spectroscopic signatures showed unusual intensity ratios that differed from pre-eclipse observations. The post-eclipse brightness enhancement could indicate either more vigorous natural outgassing than expected or possibly artificial augmentation of the object's reflectivity through technological means. The modified spectroscopic signatures might reflect changes in surface composition caused by solar heating, or they could suggest controlled alterations in outgassing patterns for purposes unknown. High-resolution imaging during the emergence period revealed a coma structure that appeared more complex and organized than before the solar eclipse. The gas and dust surrounding 3I Atlas displayed patterns that seemed almost geometrically regular, lacking the chaotic asymmetries typically associated with natural cometary outgassing. These structural anomalies in the coma provided some of the most intriguing evidence yet observed regarding 3I Atlas's potential artificial nature. While natural processes could potentially create organized patterns under specific conditions, The observed regularity seemed to suggest either unusually controlled physical processes or possibly technological influence over material distribution. The organised coma structure became a focal point for renewed speculation about 3Y Atlas's true nature. Supporters of artificial explanations pointed to the geometric patterns as evidence of technological control over outgassing processes. Advocates for natural interpretation suggested that the regularity might result from systematic rotation of an irregularly shaped nucleus or previously unknown physical phenomena associated with interstellar objects. As December progressed and 3I Atlas continued its retreat from the inner solar system, additional observations revealed ongoing changes in brightness and spectroscopic signatures that suggested either continued evolution of natural processes or possibly systematic modifications of observable characteristics. The object appeared to be gradually returning to the more subdued activity levels that had characterized its initial approach to the solar system, as if the perihelion passage had been a brief period of enhanced activity that was now subsiding in controlled fashion. This behavior was generally consistent with natural cometary evolution, yet the precision of the apparent control over activity levels raised questions about whether purely physical processes could account for such systematic changes. The final month of 3Y Atlas observations provided a fitting conclusion to one of the most mysterious and controversial astronomical encounters in modern history. The object had arrived from interstellar space carrying chemical signatures of ancient stellar environments, followed a trajectory that seemed almost too convenient to be coincidental, displayed anomalous physical and chemical properties throughout its passage, and emerged from its hidden solar encounter with characteristics that continued to challenge easy interpretation. Whether 3I Atlas ultimately represented a natural comet with unusual properties or something far more extraordinary, its study had advanced our understanding of interstellar objects, improved our techniques for detecting and analysing unusual phenomena, and demonstrated the power of international scientific cooperation when confronting potentially transformative discoveries. The encounter had also revealed important insights about the nature of scientific discovery in the modern age, the challenges of maintaining rigorous methodology while remaining open to extraordinary possibilities, and the complex dynamics between professional research and public engagement when dealing with phenomena that capture widespread imagination. As 3I Atlas gradually faded from visibility and began its journey back to the cosmic depths, it left behind a legacy of questions and possibilities that would continue to influence astronomical research and philosophical speculation for decades to come. The object had forced humanity to confront fundamental questions about our place in the universe, our readiness for contact with advanced civilizations, and our ability to recognize intelligence when it might choose to remain deliberately ambiguous. The story of 3I Atlas would be remembered not only for the specific discoveries and insights it provided, but also for the way it challenged our assumptions, expanded our imaginations, and reminded us that the universe still holds mysteries capable of surprising even our most sophisticated scientific instruments and theoretical frameworks. In the end, 3I Atlas had given humanity something precious and rare, a genuine mystery that resisted easy resolution, demanded our best scientific efforts, and reminded us that the cosmos remains full of wonders waiting to be discovered by those curious enough to look up at the stars and wonder what might be looking back. As 3I Atlas began its long journey back toward the outer solar system and eventual return to interstellar space, the scientific community found itself grappling not only with the accumulated observational data, but also with the broader implications of what the encounter might mean for our understanding of the universe and our place within it. The months of intensive study had produced an unprecedented dataset about an interstellar visitor, yet fundamental questions about the object's nature remained tantalizingly unresolved. This persistence of mystery in the face of sophisticated observation and analysis revealed something profound about the limits of current scientific methodology when confronting phenomena that might represent genuinely novel categories of cosmic objects. The ambiguity surrounding 3Y Atlas had forced researchers to develop new approaches to astronomical investigation that could accommodate multiple competing hypotheses rather than seeking immediate resolution toward a single explanation. This methodological evolution reflected a growing recognition that the universe might contain phenomena that challenge traditional frameworks for scientific classification and understanding. The theoretical work that had emerged from the 3I Atlas encounter extended far beyond the specific case of this individual object. Researchers had developed new frameworks for distinguishing natural from artificial origins in astronomical observations, explored the implications of various forms of extraterrestrial technology, and advanced our understanding of how advanced civilizations might choose to interact with emerging intelligences like humanity. These theoretical advances were perhaps as significant as any specific discoveries about 3I Atlas itself. The encounter had catalyzed a new maturity in the search for extraterrestrial intelligence, moving beyond simple assumptions about how alien contact might occur toward more sophisticated consideration of the full range of possibilities that advanced civilizations might employ for reconnaissance, communication, or interaction. The statistical analysis of 3I Atlas's trajectory had also contributed to our understanding of interstellar dynamics and the processes that govern the ejection and travel of objects between stellar systems. Even if the object's path through our solar system had been purely coincidental, the mathematical framework developed to analyze its motion had advanced techniques that would be applicable to future interstellar visitors. The chemical analysis of 3I Atlas had revealed isotopic signatures and molecular abundances that provided new insights into stellar nuclear synthesis processes operating in ancient, low metallicity environments. The object had served as a direct physical sample of material formed under conditions very different from those that created our own solar system, offering a unique window into galactic chemical evolution over cosmic time. These scientific advances ensured that the 3I Atlas encounter would be remembered as a significant contribution to multiple fields of astronomical research, regardless of whether the object ultimately proved to be natural or artificial in origin. The intensive investigation had pushed observational techniques to new levels of sophistication and demonstrated the power of international collaboration when confronting potentially transformative discoveries. Yet even as the formal scientific analysis continued, the cultural impact of 3I Atlas was proving to be equally profound and long-lasting. The encounter had captured public imagination in ways that few astronomical discoveries ever achieve, inspiring widespread interest in space science, astrobiology, and the search for extraterrestrial intelligence. Educational institutions around the world reported unprecedented enrollment in astronomy and planetary science courses, while science museums developed new exhibits exploring the implications of interstellar visitors and the possibility of alien contact. The 3I Atlas phenomenon had succeeded in making abstract concepts about cosmic exploration and extraterrestrial intelligence tangible and immediate for millions of people. The cultural response to 3I Atlas also reflected broader social and philosophical evolution in humanity's relationship with the possibility of extraterrestrial intelligence. The encounter had occurred during a period of unprecedented, official acknowledgement of unidentified aerial phenomena and growing scientific respectability for SETI research, creating a cultural moment when serious discussion of alien contact seemed both more legitimate and more urgent than ever before. This cultural evolution was perhaps most evident in the sophisticated nature of public discourse surrounding 3I Atlas. Rather than simple sensationalism or uncritical acceptance of exotic explanations, the global conversation about the object had demonstrated remarkable nuance and scientific literacy. People around the world had engaged with complex concepts in orbital mechanics, spectroscopy, and astrobiology in their efforts to understand what they were witnessing. The democratization of scientific information through social media and online platforms had enabled unprecedented public participation in the 3I Atlas investigation. Amateur astronomers had contributed meaningful observational data, retired engineers had performed sophisticated trajectory analyses, and curious individuals with no formal scientific training had found ways to participate in the collective effort to understand our mysterious visitor. This collaborative approach to scientific discovery had revealed both the potential and the challenges of citizen science in the modern era. While the broader participation had undoubtedly contributed valuable insights and perspectives that might have been missed by traditional academic approaches, It had also created challenges in distinguishing reliable analysis from speculation and wishful thinking. The three-eye atlas phenomenon had become a case study in how science operates in the modern information environment, where traditional gatekeeping mechanisms must adapt to accommodate genuine citizen contributions while filtering out the inevitable noise that accompanies any topic of intense public interest. As the object continued its retreat from the inner solar system, the intensity of observation and analysis gradually decreased. But the broader implications of the encounter continued to resonate through scientific and cultural communities worldwide. The questions raised by Three-Eye Atlas would likely influence research priorities and theoretical development for decades to come. The encounter had demonstrated the critical importance of preparedness for future interstellar visitors. The challenges of studying 3-Cir Atlas, from its delayed recognition to the observational gaps during perihelion, had revealed significant limitations in our current infrastructure for detecting and analysing unusual objects in the solar system. Space agencies and research institutions began serious discussions about investments needed to ensure that future encounters could be studied more effectively. Proposals emerged for dedicated interstellar object tracking networks, rapid response observational capabilities, and potentially even spacecraft missions designed to intercept and study visiting objects in unprecedented detail. These infrastructure development discussions reflected a growing recognition that interstellar visitors might be more common than previously assumed, and that each encounter represented a precious opportunity for discovery that should not be wasted due to inadequate preparation or resources. The Vera Rubin Observatory, scheduled to begin full operations in the coming years, promised to revolutionize the detection of interstellar objects by conducting systematic surveys of the entire visible sky with unprecedented depth and frequency. The observatory might detect dozens or even hundreds of interstellar visitors over its operational lifetime, providing a much larger sample for study and potentially revealing whether objects like Three-Eye Atlas represented rare anomalies or examples of a broader population of unusual cosmic wanderers. The prospect of frequent interstellar visitor detections raised fascinating questions about what such a larger sample might reveal. If the universe indeed contained a population of artificial objects, statistical analysis of multiple detections might reveal patterns that would be invisible when studying individual cases like Three-Eye Atlas in isolation. Alternatively, a larger sample might demonstrate that objects like Three-Eye Atlas represented natural phenomena that were simply rare enough to appear anomalous when encountered individually. The accumulation of multiple cases could provide the statistical foundation needed to develop more sophisticated theoretical frameworks for understanding interstellar object populations. The Three-Eye Atlas encounter had also highlighted the importance of rapid response capabilities when dealing with transient phenomena. The object had been approaching our solar system for months before its interstellar nature was recognized, and crucial observational opportunities might have been lost due to delays in detection and initial analysis. Future preparedness would require not only better detection capabilities, but also improved procedures for rapid classification and response when unusual objects were identified. The astronomical community would need to develop protocols for quickly mobilizing observational resources and coordinating international efforts when potentially significant discoveries emerged. The challenges of studying Three-Eye Atlas had also revealed the limitations of ground-based observation when dealing with objects that follow trajectories carrying them behind the Sun or into other geometrically challenging positions. Future spacecraft missions designed specifically for interstellar object encounters might be necessary to ensure complete observational coverage during crucial phases of visitor encounters. The technical requirements for such missions would be formidable, involving spacecraft capable of rapid trajectory changes to intercept objects with unpredictable arrival times and directions. The development of such capabilities would represent a significant advancement in space exploration technology, with applications extending far beyond interstellar object studies. As winter settled over the Northern Hemisphere and Three-Eye Atlas continued its gradual fade from visibility, the global community that had formed around its study began to consider what lessons might be drawn from the encounter and how they should influence future approaches to cosmic exploration and the search for extraterrestrial intelligence. The persistence of ambiguity in the Three-Eye Atlas case had demonstrated both the power and the limitations of current scientific methodology when confronting genuinely novel phenomena, while sophisticated observation and analysis had revealed unprecedented detail about the object's composition, structure, and behavior. Fundamental questions about its ultimate nature remained unresolved. This outcome challenged traditional expectations about the relationship between observational capability and scientific understanding. The 3-Eye Atlas encounter suggested that there might be categories of phenomena that would remain ambiguous even under intensive study with the most advanced available instruments and techniques. The implications of this possibility extended far beyond the specific case of 3-Eye Atlas to encompass broader questions about the nature of scientific knowledge and the criteria for accepting or rejecting extraordinary claims. How should the scientific community respond when confronted with phenomena that resist clear resolution despite thorough investigation? The 3-Eye Atlas experience suggested that maintaining multiple working hypotheses might be more appropriate than seeking premature closure when dealing with genuinely ambiguous evidence. This approach required a level of intellectual humility and tolerance for uncertainty that challenged traditional scientific preferences for definitive conclusions and clear categorization. The encounter had also revealed the importance of interdisciplinary collaboration when studying phenomena that might bridge multiple domains of knowledge. The 3-Eye Atlas investigation had required expertise in astronomy, planetary science, chemistry, physics, engineering, and even psychology and philosophy to fully address all the questions raised by the object's behavior and characteristics. This interdisciplinary approach had proven essential for developing comprehensive understanding that no single field of study could have achieved independently. Future encounters with unusual phenomena would likely require similar collaborative efforts that transcended traditional academic boundaries and institutional structures. The cultural dimensions of the 3-Eye Atlas encounter had proven to be as significant as the scientific aspects, revealing important insights about how humanity might respond to genuine contact with extraterrestrial intelligence. The global conversation sparked by the object had demonstrated both our species' deep fascination with the possibility of cosmic contact and our capacity for sophisticated engagement with complex and ambiguous phenomena. The response to 3-Eye Atlas had also revealed potential challenges that might arise if future encounters involved less ambiguous evidence of extraterrestrial intelligence. The intense speculation and debate surrounding an object that maintained plausible, natural explanations suggested that unambiguous evidence of alien technology might trigger even more dramatic cultural responses. The need for thoughtful preparation for such possibilities became apparent through reflection on the 3-Eye Atlas experience. How might humanity respond to definitive evidence of extraterrestrial intelligence? What institutional and cultural frameworks would be needed to manage such a discovery responsibly and constructively? These questions extended beyond the realm of scientific investigation to encompass diplomacy, security, philosophy, and ethics. The 3-Eye Atlas encounter had provided a valuable preview of the kinds of challenges that might emerge if humanity ever faced genuine contact with advanced alien civilizations. As 3-Eye Atlas continued its journey toward the outer solar system and eventual return to interstellar space, its gradual fade from visibility marked the end of direct observation, but not the conclusion of its influence on human understanding and imagination. The object would soon be too distant and faint for even our most powerful telescopes to detect, returning to the cosmic anonymity from which it had briefly emerged. Yet the legacy of 3-Eye Atlas would persist long after the object itself had vanished from our instruments. The encounter had changed how we think about interstellar visitors, the search for extraterrestrial intelligence, and the nature of scientific discovery in an age of global communication and citizen participation. The theoretical frameworks developed during the 3-Eye Atlas investigation would influence how future unusual objects were studied and interpreted. The observational techniques refined during the encounter would be applied to subsequent discoveries. The cultural conversations sparked by the object would continue to shape public engagement with space science and astrobiology. Perhaps most importantly, 3-Eye Atlas had demonstrated that the universe still holds genuine mysteries capable of challenging our most sophisticated scientific capabilities and theoretical understanding. In an age when many cosmic phenomena seem to have been catalogued and explained, the encounter had reminded us that discovery and wonder remain central to the human relationship with the cosmos. The objects had also highlighted the profound questions that await us as our observational capabilities continue to improve and our exploration of the universe becomes more comprehensive. What other visitors might be travelling through interstellar space, carrying secrets from distant worlds and ancient times? How many mysteries remain hidden in the vast emptiness between stars, waiting for the right combination of technology and curiosity to reveal their presence? The story of 3i Atlas had shown that each new discovery about our cosmic environment raises as many questions as it answers, creating an expanding frontier of knowledge that stretches towards horizons we can barely imagine. The encounter had been a reminder that we live in a universe full of possibilities that challenge our assumptions and expand our understanding of what might be possible on cosmic scales. As the final observations of 3i Atlas were completed, and the object began its journey back to the interstellar medium, astronomers around the world turned their attention to other projects while maintaining the enhanced awareness and improved techniques that had been developed during the encounter. The search for additional interstellar visitors intensified, with researchers hoping that 3i Atlas might represent the first of many such objects that would be detected in coming years. The Vera Rubin Observatory and other next-generation surveys promised to revolutionize our ability to detect and track unusual objects, potentially revealing a rich population of interstellar wanderers that had previously escaped notice. The theoretical work initiated by 3i Atlas continued to develop and expand, with researchers exploring increasingly sophisticated models for distinguishing natural from artificial phenomena and developing frameworks for interpreting evidence of possible extraterrestrial technology. These efforts represented important advances in our conceptual preparation for potential future contact with alien intelligence. The educational and outreach programs inspired by 3i Atlas evolved into ongoing efforts to maintain public engagement with space science and astrobiology. The encounter had demonstrated the powerful potential for astronomical discoveries to capture public imagination and inspire interest in scientific careers and space exploration. Museums and planetariums developed permanent exhibits exploring the implications of interstellar visitors and the search for extraterrestrial intelligence, while educational curricula were updated to include discussion of how science operates when confronting genuinely ambiguous phenomena that resist easy interpretation. The 3i Atlas encounter had also influenced policy discussions about space exploration priorities and the allocation of resources for detecting and studying unusual objects. Government agencies and international organizations began to consider what investments might be needed to ensure adequate preparedness for future potentially transformative discoveries. These policy discussions reflected growing recognition that encounters like 3i Atlas might become more frequent as our observational capabilities improved, and that society needed frameworks for responding constructively to discoveries that could challenge fundamental assumptions about our place in the universe. As months passed and 3i Atlas continued its retreat toward the outer solar system, the intensity of active investigation gradually decreased, but the object remained a subject of ongoing analysis and speculation. Researchers continued to mine the accumulated dataset for new insights, while theorists explored the broader implications of the encounter for our understanding of cosmic phenomena. The persistent ambiguity surrounding 3i Atlas's ultimate nature ensured that it would remain a subject of discussion and debate for years or decades to come. Unlike astronomical discoveries that provided clear answers to specific questions, 3i Atlas had opened up entire new domains of inquiry that would require sustained investigation to fully explore. The object had demonstrated that some of the most significant scientific discoveries might be those that raise new questions, rather than providing definitive answers to old ones. By challenging our existing frameworks for understanding cosmic phenomena, 3i Atlas had created opportunities for conceptual advancement that might ultimately prove more valuable than any specific factual discoveries about the object itself. The encounter had also highlighted the importance of maintaining openness to extraordinary possibilities while pursuing rigorous scientific methodology. The balance between appropriate skepticism and genuine curiosity that had characterized the best aspects of 3I Atlas research, provided a model for how the scientific community might approach future encounters with phenomena that challenge existing paradigms. As the winter of 2025 deepened and 3I Atlas became too faint for continued observation, the global community that had formed around its study began to contemplate what the encounter might mean for humanity's future relationship with the cosmos. The object had provided a glimpse of how our species might respond to genuine mystery and potential contact with intelligences beyond Earth. The sophisticated and collaborative response to 3I Atlas offered reasons for optimism about humanity's readiness for cosmic discovery and potential contact with extraterrestrial intelligence. The encounter had demonstrated our capacity for international cooperation, scientific rigor, and thoughtful consideration of extraordinary possibilities. Yet the experience had also revealed challenges and limitations that would need to be addressed if humanity were to be fully prepared for future encounters that might be even more significant than 3I Atlas. The need for improved detection capabilities, rapid response protocols, and frameworks for managing potentially transformative discoveries had become apparent through the encounter. The lessons learned from 3I Atlas would influence how humanity prepared for and responded to future cosmic discoveries, ensuring that the encounter's legacy extended far beyond the specific case of this individual mysterious visitor. The object had changed not only our understanding of interstellar phenomena, but also our approach to the perpetual human quest to understand our place in the vast and wonder-filled universe that surrounds us. In the end, 3I Atlas had given humanity something precious and transformative, a genuine encounter with the unknown that challenged our assumptions, expanded our imagination, and reminded us that the cosmos still holds mysteries capable of inspiring awe and wonder, even in an age of sophisticated scientific understanding. Whether natural or artificial, ancient or contemporary, the object had served as a cosmic messenger that carried profound questions about intelligence, consciousness, and the nature of existence on scales that stretch from our small planet to the furthest reaches of the galaxy and beyond. The profound questions raised by 3I Atlas extended far beyond the realm of astronomy into domains of philosophy, psychology, and even spirituality that spoke to the deepest aspects of human nature and our relationship with the unknown. The encounter had forced humanity to confront fundamental questions about consciousness, intelligence, and the meaning of existence on cosmic scales that stretched our conceptual frameworks in ways both exciting and unsettling. One of the most significant philosophical implications of the 3I Atlas encounter involved the nature of intelligence itself and how it might manifest across different evolutionary pathways and technological developments. If the object were indeed artificial, it would represent our first direct evidence that intelligence could emerge and survive on cosmic timescales far exceeding anything in human experience. The possibility that 3I Atlas might be millions or billions of years old challenged anthropocentric assumptions about the nature and development of consciousness. Human intelligence had emerged through biological evolution operating over a relatively brief period in cosmic terms, yet 3I Atlas suggested that intelligence might take forms and operate on timescales that were almost incomprehensible from our terrestrial perspective. This temporal dimension of potential alien intelligence raised profound questions about the relationship between consciousness and time. How might minds that operated on geological or astronomical timescales perceive reality? What would constitute meaningful experience for intelligences that might witness the birth and death of stars as routine events in their existence? The reconnaissance hypothesis that had been developed around 3I Atlas also implied forms of intelligence that were patient and methodical, beyond human comprehension. If the object were indeed conducting systematic surveys of stellar systems across the galaxy, it might represent part of a research program spanning millions of years and involving the detailed study of countless worlds. Such a perspective on intelligence suggested that what we considered the fundamental urgency of scientific discovery and technological development might appear as mere momentary fluctuations to minds operating on cosmic scales. The encounter with 3I Atlas forced consideration of how human civilization might appear to intelligences with such expanded temporal perspectives. These philosophical implications extended beyond abstract speculation to encompass practical questions about how humanity might appropriately respond to contact with intelligences that operated on such different scales of experience and understanding. Traditional approaches to communication and interaction might be entirely inadequate when dealing with minds that thought and acted on cosmic rather than terrestrial timescales. The Three-Eye Atlas encounter had also highlighted the role of uncertainty and ambiguity as fundamental aspects of cosmic exploration and discovery. Rather than providing clear answers to specific questions, the object had demonstrated how the most significant encounters with the unknown might be characterized by persistent mystery rather than definitive resolution. This persistence of ambiguity challenged human preferences for clarity and closure, suggesting that some of the most profound cosmic phenomena might be inherently resistant to complete understanding through conventional scientific approaches. The universe might contain categories of experience and reality that remained mysterious even under intensive study with our most sophisticated analytical techniques. The psychological impact of sustained ambiguity had become apparent throughout the Three-Eye Atlas investigation. Researchers, media, and the general public had all struggled with the challenge of maintaining interest and engagement with a phenomenon that refused to resolve into clear categories or definitive explanations. This psychological dimension revealed important insights about human nature and our relationship with the unknown. While our species demonstrated remarkable capacity for curiosity and investigation, when confronted with mystery, we also showed strong preferences for narrative resolution and categorical understanding that might be ill-suited for dealing with genuinely cosmic phenomena. The Three-Eye Atlas experience suggested that future encounters with advanced alien intelligence might require psychological and cultural preparation that went beyond technical or scientific readiness. Humanity might need to develop greater tolerance for ambiguity and uncertainty if we were to engage constructively with phenomena that challenged our existing frameworks for understanding reality. The cultural response to Three-Eye Atlas had also revealed fascinating insights about how information spreads and evolves in the modern global communication environment. The story of the mysterious interstellar visitor had been shaped not only by scientific observation and analysis, but also by social media dynamics, cultural expectations, and psychological needs that influenced how evidence was interpreted and shared. The democratization of information about Three-Eye Atlas had created unprecedented opportunities for public engagement with cutting-edge scientific research, but it had also demonstrated how complex technical information could be simplified, distorted, or sensationalized as it spread through various media channels and social networks. The evolution of the Three-Eye Atlas narrative from scientific discovery to cultural phenomenon illustrated both the potential and the challenges of conducting research in an era of instant global communication. While broader public engagement could contribute valuable perspectives and insights, it also created pressures for premature conclusions and sensational interpretations that might compromise the careful methodological approaches required for rigorous scientific investigation. These communication dynamics would likely become even more significant if humanity ever encountered less ambiguous evidence of extraterrestrial intelligence. The Three-Eye Atlas experience provided valuable lessons about how to manage the flow of information about potentially transformative discoveries while maintaining both scientific integrity and appropriate public engagement. The international cooperation that had characterized the Three-Eye Atlas investigation offered encouraging insights about humanity's capacity for collaborative response to cosmic challenges. Despite ongoing geopolitical tensions and national rivalries, the scientific community had demonstrated remarkable unity and coordination when confronted with a potentially unprecedented discovery. This collaborative response suggested that encounters with genuinely cosmic phenomena might have the power to transcend terrestrial divisions and unite humanity around shared questions about our place in the universe. The Three-Eye Atlas experience hinted at the possibility that contact with extraterrestrial intelligence could serve as a catalyst for greater global cooperation and shared purpose. Yet the encounter had also revealed potential challenges that might arise if future discoveries provided less ambiguous evidence of alien intelligence. The intense speculation and debate surrounding Three-Eye Atlas had sometimes generated more heat than light, suggesting that definitive proof of extraterrestrial visitors might trigger even more dramatic and potentially divisive cultural responses. The need for thoughtful preparation for such possibilities had become apparent through reflection on the Three-Eye Atlas experience. How might humanity respond to unambiguous evidence of extraterrestrial intelligence? What institutional frameworks would be needed to manage such discoveries constructively? How could we ensure that potential contact scenarios would enhance, rather than threaten, human unity and progress? These questions extended beyond the realm of science policy to encompass diplomacy, security, ethics, and cultural development. The Three-Eye Atlas encounter had provided valuable insights into these challenges while highlighting the need for continued discussion and preparation as our observational capabilities improved and the likelihood of significant discoveries increased. The theological and spiritual implications of the Three-Eye Atlas encounter had also generated significant discussion within religious communities and among individuals grappling with questions about the relationship between scientific discovery and spiritual understanding. The possibility of extraterrestrial intelligence raised profound questions about the uniqueness of human consciousness and our special relationship with the divine or transcendent. Different religious traditions had responded to these questions in various ways, with some finding the possibility of alien intelligence compatible with their theological frameworks, while others struggled with implications that seemed to challenge anthropocentric interpretations of spiritual reality. The Three-Eye Atlas encounter had catalyzed renewed theological discussion about the scale and nature of creation, consciousness, and meaning. These spiritual dimensions of the encounter reflected deeper human needs for understanding our place in a cosmic order that might extend far beyond terrestrial experience. The possibility that Three-Eye Atlas represented evidence of intelligence on cosmic scales forced consideration of what such intelligence might mean for human concepts of purpose, meaning, and spiritual significance. The scientific investigation of Three-Eye Atlas had also advanced our understanding of the methodological and conceptual challenges involved in detecting and studying phenomena that might represent genuinely novel categories of cosmic objects. The encounter had pushed observational techniques to new levels of sophistication, while revealing fundamental limitations in our current approaches to astronomical research. The development of new analytical frameworks for distinguishing natural from artificial phenomena had required integration of insights from multiple scientific disciplines, ranging from astronomy and planetary science to computer science and information theory. This interdisciplinary approach had proven essential for addressing questions that no single field of study could have tackled independently. The theoretical work initiated by Three-Eye Atlas had also contributed to broader advances in astrobiology and the search for extraterrestrial intelligence. Researchers had developed more sophisticated models for how advanced civilizations might choose to explore and interact with other stellar systems, expanding our conceptual framework for what contact scenarios might actually look like if they occurred. These theoretical advances ensured that the Three-Eye Atlas encounter would influence scientific thinking long after the object itself had faded from observation. The conceptual tools and analytical approaches developed during the investigation would be applicable to future discoveries and would help ensure that unusual phenomena received appropriate scientific attention rather than being dismissed or misinterpreted. The encounter had also demonstrated the importance of maintaining institutional memory and analytical capability for dealing with rare but potentially significant phenomena. The intensive investigation of Three-Eye Atlas had required rapid mobilization of expertise and resources that might not be readily available if similar discoveries occurred without adequate preparation. Future preparedness would require not only improved detection and observation capabilities, but also institutional frameworks for maintaining the specialized knowledge and analytical tools needed to study unusual objects effectively. The Three-Eye Atlas experience had revealed how quickly such specialized knowledge could be needed and how difficult it might be to develop on short notice. The educational legacy of Three-Eye Atlas extended far beyond its immediate scientific implications to encompass broader lessons about scientific methodology, critical thinking, and the nature of discovery in an age of rapid technological advancement and global communication. The encounter had provided a real-world case study in how science operates when confronting genuinely novel phenomena that challenge existing theoretical frameworks. Students and educators around the world had used the Three-Eye Atlas story to explore concepts in astronomy, physics, chemistry, statistics, and philosophy of science. The encounter had demonstrated how multiple lines of evidence could support different interpretations of the same phenomena, highlighting the importance of maintaining multiple working hypotheses when dealing with ambiguous data. The Three-Eye Atlas case had also illustrated the collaborative nature of modern scientific research and the ways that discoveries emerge through the collective efforts of researchers working across institutional and national boundaries. This collaborative dimension provided valuable insights about how scientific knowledge develops and evolves in response to new observations and theoretical challenges. The encounter had been particularly valuable for demonstrating how science operates at the boundaries of the known, where careful methodology must be balanced with openness to extraordinary possibilities. The Three-Eye Atlas investigation had shown how researchers could maintain appropriate skepticism while seriously exploring hypotheses that challenged conventional understanding. As Three-Eye Atlas continued its journey toward the outer solar system and eventual return to interstellar space, its scientific legacy was being integrated into ongoing research programs that would continue to benefit from the techniques and insights developed during the encounter. The object had catalyzed advances in observational astronomy, theoretical astrophysics, and astrobiology that would influence these fields for decades to come. The search for additional interstellar visitors had intensified significantly following the Three-Eye Atlas encounter, with researchers applying the lessons learned from this investigation to improve detection and analysis of future objects. The Vera Rubin Observatory and other next-generation surveys were being optimized to identify unusual objects more quickly and trigger rapid response observations that could maximize scientific return from brief encounters. The theoretical frameworks developed around Three-Eye Atlas were also being applied to reanalysis of previous astronomical discoveries that might have been misinterpreted or inadequately studied. Researchers were examining archival data for evidence of other unusual objects that might have been dismissed as instrumental artifacts or natural phenomena when first observed. This retrospective analysis had already identified several candidate objects that might warrant renewed investigation using the more sophisticated analytical approaches developed during the Three-Eye Atlas encounter. The possibility that other unusual visitors might have passed through our solar system unrecognized added urgency to efforts to improve our detection and analysis capabilities. The international cooperation that had characterized the Three-Eye Atlas investigation was also being institutionalized through new frameworks for coordinating response to unusual astronomical discoveries. Space agencies and research institutions were developing protocols for rapid information sharing and resource coordination when potentially significant objects were detected. These institutional developments represented important progress toward ensuring that future encounters could be studied more effectively than had been possible with Three-Eye Atlas. The object had revealed both the power of international scientific cooperation and the challenges of organizing such cooperation on short notice when dealing with time-sensitive phenomena. The cultural impact of Three-Eye Atlas was also being studied and analyzed as a phenomenon worthy of investigation in its own right. Sociologists, psychologists, and communications researchers were examining how the story had spread and evolved through various media channels and social networks, providing insights that might be valuable for managing future discoveries with potentially greater cultural significance. These studies were revealing fascinating insights about how scientific information is processed, interpreted, and shared in the modern global communication environment. The Three-Eye Atlas story had demonstrated both the potential for sophisticated public engagement with complex scientific concepts and the challenges of maintaining accuracy and nuance when information spreads rapidly through diverse media channels. The lessons learned from the cultural response to Three-Eye Atlas were being incorporated into science communication strategies and public engagement approaches that might be needed if future discoveries provided less ambiguous evidence of extraterrestrial intelligence. The encounter had provided a valuable preview of how humanity might respond to genuinely transformative cosmic discoveries. As winter gave way to spring and Three-Eye Atlas became too faint for continued detailed observation, the global community that had formed around its study began to consider what the encounter might mean for the future of human cosmic exploration and our search for understanding about our place in the universe. The object had demonstrated that interstellar space might contain phenomena that challenge our most fundamental assumptions about the nature of cosmic objects and the distinction between natural and artificial origins. Whether Three-Eye Atlas ultimately proved to be a natural comet with unusual characteristics or something far more extraordinary, its study had expanded our conceptual framework for what might be possible on cosmic scales. The encounter had also highlighted the precious and ephemeral nature of opportunities for cosmic discovery. Three-Eye Atlas had provided only a brief window for detailed study before returning to the interstellar medium, reminding us that the most significant discoveries might come and go quickly if we are not prepared to recognize and investigate them effectively. This temporal dimension of cosmic discovery had important implications for how humanity approached the search for extraterrestrial intelligence and the investigation of unusual phenomena. The Three-Eye Atlas experience suggested that preparation and rapid response capability might be more important than sustained long-term observation when dealing with transient visitors from interstellar space. The philosophical implications of Three-Eye Atlas would continue to resonate long after the object itself had vanished from our instruments. The encounter had forced consideration of profound questions about intelligence, consciousness, and meaning on cosmic scales that stretched our conceptual abilities and challenged anthropocentric assumptions about the nature of mind and purpose in the universe. Whether natural or artificial, Three-Eye Atlas had served as a cosmic mirror that reflected back questions about who we are, what we might become, and how we fit into a universe that appears to be far stranger and more complex than our ancestors could have imagined. The encounter had reminded us that we live in a cosmos full of mystery and possibility, where the next discovery might fundamentally transform our understanding of reality itself. The story of Three-Eye Atlas was ultimately a story about human curiosity, ingenuity, and our perpetual quest to understand the world around us. The encounter had demonstrated both the power and the limitations of our current scientific capabilities, while pointing toward future possibilities that might exceed our wildest current imagination. As the mysterious visitor continued its journey back to the cosmic deep, it carried with it the hopes, dreams, and questions of a species that had briefly glimpsed something that might have been extraordinary or might have been perfectly ordinary, but had undoubtedly been profound in its impact on our understanding of what it means to be human in a universe full of wonders waiting to be discovered. The legacy of Three-Eye Atlas extended into realms of human experience that transcended the boundaries of traditional scientific investigation, touching on the deepest questions about consciousness, purpose, and our species' destiny among the stars. As the mysterious visitor faded into the cosmic background, it left behind transformations in how we think about intelligence, both terrestrial and potentially extraterrestrial, that would influence human development for generations to come. The encounter had revealed the profound interconnectedness between scientific discovery and cultural evolution, demonstrating how a single astronomical object could catalyze shifts in perspective that rippled through education, philosophy, religion, and even politics. The questions raised by Three-Eye Atlas had forced humanity to confront assumptions about our uniqueness and significance that had shaped civilization for millennia. Perhaps most significantly, the Three-Eye Atlas phenomenon had illustrated the evolution of human consciousness itself, showing how our species was developing new capacities for dealing with cosmic-scale phenomena and genuinely ambiguous information. The global response to the mysterious visitor had demonstrated remarkable sophistication in processing complex, uncertain data, while maintaining multiple competing interpretations without succumbing to premature closure or dogmatic certainty. This cognitive evolution represented a crucial development in human intellectual maturity, suggesting that our species might be developing the conceptual tools needed to navigate an increasingly complex and mysterious universe. The ability to maintain uncertainty while continuing productive investigation might prove essential for dealing with future discoveries that challenge even more fundamental assumptions about reality. The 3i Atlas encounter had also highlighted the emergence of new forms of collective intelligence enabled by modern communication technologies. The global collaboration that had characterized the investigation involved not just professional scientists, but millions of curious individuals who contributed observations, analysis, and insights through social media platforms, citizen science projects, and online discussion forums. This distributed approach to cosmic investigation represented a significant evolution in how humanity might approach the study of phenomena that require perspectives and resources exceeding those available to any individual institution or nation. The 3i Atlas experience suggested that our species was developing new capabilities for collective problem-solving that might be essential for addressing the challenges and opportunities of an expanding cosmic presence. The encounter had simultaneously demonstrated both the power and the fragility of human scientific institutions when confronted with potentially transformative discoveries. While the international scientific community had responded with remarkable cooperation and sophistication, the investigation had also revealed limitations and biases that might prove problematic if future encounters provided less ambiguous evidence of extraterrestrial intelligence. The tendency toward premature categorization, the influence of cultural expectations on data interpretation, and the challenges of maintaining rigorous methodology under intense public scrutiny had all become apparent during the 3i Atlas investigation. These limitations highlighted areas where human scientific culture might need to evolve to better handle discoveries that could fundamentally challenge existing paradigms. The philosophical implications of 3i Atlas continue to reverberate through academic and popular discussions about the nature of mind, consciousness, and intelligence on cosmic scales. The possibility that the object represented evidence of intelligence operating on timescales measured in millions or billions of years had forced reconsideration of what consciousness might mean in cosmic contexts. Traditional human concepts of intelligence were deeply rooted in biological evolution and individual lifespans measured in decades. The prospect of minds that might operate on geological or astronomical timescales challenged these anthropocentric frameworks and suggested that consciousness might take forms that were almost incomprehensible from terrestrial perspectives. This expansion of our conceptual framework for intelligence had implications extending far beyond the specific case of 3i Atlas to encompass broader questions about artificial intelligence, machine consciousness, and the potential future evolution of human awareness itself. If intelligence could persist and develop over cosmic timescales, what might that suggest about the ultimate destiny of consciousness in the universe? The encounter had also catalyzed renewed interest in the philosophical implications of the search for extraterrestrial intelligence, moving beyond simple questions about whether we are alone, to explore more complex issues about the nature of communication, understanding, and relationship between different forms of consciousness that might have evolved under radically different conditions. The possibility that 3i Atlas represented a form of intelligence that operated through physical presence rather than electromagnetic communication had expanded theoretical frameworks for how advanced civilizations might choose to explore and interact with other stellar systems. This physical approach to interstellar contact might be more common than radio or optical communication, suggesting that our search strategies might need fundamental revision. The reconnaissance hypothesis developed around 3i Atlas had also raised profound ethical questions about the rights and responsibilities of advanced civilizations when encountering less developed species. If 3i Atlas were indeed conducting observations of human civilization, what moral frameworks might govern such surveillance? How might advanced intelligences balance scientific curiosity with respect for the autonomy and privacy of emerging civilizations? These ethical dimensions of potential contact had received insufficient attention in previous discussions of extraterrestrial intelligence, yet the 3i Atlas encounter suggested they might be crucial for understanding how actual contact scenarios might unfold. The object had forced consideration of humanity not just as potential discoverers of alien intelligence, but as potential subjects of alien investigation. This reversal of perspective had psychological implications that were still being processed by individuals and institutions around the world. the possibility that human civilization was being observed and evaluated by intelligences with capabilities far exceeding our own, raised questions about privacy, autonomy, and dignity that had no precedent in human experience. The Three-Eye Atlas encounter had also influenced ongoing debates about the appropriate balance between transparency and secrecy when dealing with potentially transformative discoveries. The object's study had been conducted with unprecedented openness, yet some observers argued that certain aspects of the investigation should have been kept confidential to avoid premature speculation and potential public panic. These discussions about information management had important implications for how future discoveries might be handled, particularly if they provided less ambiguous evidence of extraterrestrial intelligence. The Three-Eye Atlas experience had demonstrated both the benefits of open scientific investigation and the challenges of managing complex information in an era of instant global communication. The encounter had also revealed the continuing influence of cultural and national differences in how extraordinary claims were evaluated and discussed. While the scientific community had generally maintained consistent methodological standards across different countries and institutions, public responses had varied significantly based on cultural backgrounds, religious traditions, and national perspectives on the possibility of extraterrestrial intelligence. These cultural variations suggested that future encounters with potentially more significant phenomena might generate diverse responses that could complicate efforts to develop unified human approaches to cosmic discovery and potential contact. The Three-Eye Atlas experience highlighted the need for continued dialogue about how different cultural perspectives might be integrated into coherent global responses to transformative discoveries. The economic implications of the Three-Eye Atlas encounter were also beginning to emerge as the initial excitement subsided and longer-term consequences became apparent. The intensive investigation had required significant investments of telescope time, analytical resources, and human expertise that had been diverted from other research priorities. While most observers considered these investments worthwhile, regardless of the ultimate resolution of questions about the object's nature, the encounter had highlighted the resource requirements for studying unusual phenomena effectively. Future preparedness for similar encounters would likely require sustained investments in detection capabilities, rapid response infrastructure, and analytical tools that might remain unused for years or decades between significant discoveries. The challenge of maintaining such capabilities in the absence of immediate applications would require new approaches to funding and institutional organization that had not been necessary when dealing with more predictable astronomical phenomena. The Three-Eye Atlas encounter had also generated significant economic activity through increased public interest in space science, astronomy, education, and related technologies. Science museums, planetariums, and educational institutions had experienced unprecedented demand for programming related to the mysterious visitor, while publishers and media companies had found strong markets for content exploring the implications of the encounter. This economic dimension suggested that encounters with unusual cosmic phenomena might have broader social and economic benefits that extended well beyond their immediate scientific value. The Three-Eye Atlas phenomenon had demonstrated how astronomical discoveries could stimulate public interest in science and technology in ways that might influence educational choices and career development for years to come. The technological advances catalyzed by the Three-Eye Atlas investigation were also beginning to influence other areas of astronomical research and space exploration. The sophisticated analytical techniques developed for studying the mysterious visitor were being applied to other challenging observational problems, while the coordination mechanisms developed for the international investigation were being adapted for use in other collaborative research programs. The rapid response protocols developed during the Three-Eye Atlas encounter were being institutionalized to ensure that future unusual discoveries could be investigated more effectively. Space agencies and research institutions were implementing permanent frameworks for coordinating observations and sharing data when potentially significant objects were detected. These institutional developments represented important progress toward ensuring that humanity would be better prepared for future encounters that might be even more significant than Three-Eye Atlas. The object had revealed both the potential for remarkable international cooperation and the challenges of organizing such cooperation quickly when dealing with time-sensitive phenomena. The educational impact of 3Phi Atlas was also proving to have lasting effects on how science was taught and communicated to students and the general public. The encounter had provided a compelling real-world example of how scientific investigation operates when confronting genuinely novel phenomena, illustrating concepts in methodology, uncertainty, and collaborative research that were often difficult to convey through traditional educational approaches. Curriculum developers and science educators were incorporating the 3I Atlas story into courses ranging from introductory astronomy to graduate seminars in philosophy of science. The encounter provided rich material for exploring how evidence is evaluated, how competing hypotheses are maintained and tested, and how scientific knowledge evolves in response to new observations. The case study aspects of 3I Atlas were particularly valuable for demonstrating the human dimensions of scientific research, showing how individual researchers and institutions responded to phenomena that challenged existing frameworks and required rapid adaptation of investigative strategies. Students could observe how real scientists dealt with uncertainty, managed disagreement, and maintained intellectual integrity while exploring extraordinary possibilities. The 3I Atlas encounter had also influenced public understanding of how modern scientific research operates, revealing the collaborative and international nature of contemporary astronomical investigation. Many people have been surprised to learn how extensively researchers around the world shared data, coordinated observations, and built upon each other's work when studying phenomena of mutual interest. This educational dimension had important implications for public support of scientific research and international cooperation. The 3I Atlas investigation had demonstrated the practical benefits of collaborative approaches to cosmic investigation, while highlighting the resources and institutional frameworks needed to support such collaboration effectively. As 3I Atlas continued its journey toward the outer reaches of the solar system and eventual return to interstellar space, the astronomical community was applying lessons learned from the encounter to improve preparedness for future discoveries. The Vera Rubin Observatory and other next-generation survey instruments were being optimized to detect unusual objects more quickly and trigger coordinated follow-up observations that could maximize scientific return from brief encounters. The success of international cooperation during the 3I Atlas investigation had also inspired new frameworks for sharing telescope time, coordinating observations, and pooling analytical resources when studying phenomena that might require rapid, intensive investigation. These institutional developments would ensure that future unusual visitors could be studied more effectively than had been possible with 3I Atlas. The theoretical frameworks developed during the 3I Atlas encounter were also being refined and expanded to provide better tools for distinguishing natural from artificial phenomena when studying unusual objects. Researchers had identified specific observational signatures that might indicate technological rather than natural origins, while developing more sophisticated statistical approaches for evaluating the significance of unusual characteristics. These analytical advances would be crucial for ensuring that future encounters with potentially artificial objects could be recognized and studied appropriately. The 3I Atlas experience had revealed how challenging it could be to distinguish between exotic natural phenomena and possible evidence of extraterrestrial technology, highlighting the need for more sophisticated diagnostic tools. The search for additional interstellar visitors had also intensified significantly following the 3I Atlas encounter. Researchers were applying improved detection techniques to archival data, searching for evidence of other unusual objects that might have been overlooked or misclassified when first observed. This retrospective analysis had already identified several candidate objects that warranted renewed investigation using the analytical approaches developed during the 3I Atlas encounter. The possibility that other unusual visitors had passed through our solar system, unrecognized, added urgency to efforts to improve detection and analysis capabilities. The 3I Atlas encounter had also influenced discussions about more ambitious approaches to studying interstellar visitors, including the possibility of developing spacecraft missions specifically designed to intercept and study such objects in unprecedented detail. The technical challenges would be formidable, requiring rapid trajectory changes to intercept objects with unpredictable arrival times and directions. Such missions would represent significant advances in space exploration capability, with applications extending far beyond interstellar object studies. The development of rapid response spacecraft systems could revolutionize our ability to investigate transient phenomena throughout the solar system while providing valuable experience for eventual interstellar exploration missions. As the final observations of 3I Atlas were completed, and the object began to fade beyond the detection limits of even our most powerful telescopes, the global community that had formed around its study was left to contemplate what the encounter had revealed about humanity's readiness for cosmic discovery and potential contact with extraterrestrial intelligence. The sophisticated and collaborative response to 3I Atlas offered reasons for optimism about our species' capacity for dealing with genuinely transformative discoveries. The encounter had demonstrated our ability to maintain scientific rigor while seriously exploring extraordinary possibilities, to cooperate across national and institutional boundaries when confronting shared challenges, and to engage productively with phenomena that resisted easy categorization or understanding. Yet the experience had also revealed areas where human scientific culture and institutional frameworks might need further development if we were to be fully prepared for discoveries that could challenge even more fundamental assumptions about reality. The tendency toward premature closure, the influence of cultural expectations on data interpretation, and the challenges of maintaining methodological rigor under intense public scrutiny had all become apparent during the investigation. The lessons learned from 3I Atlas would undoubtedly influence how humanity prepared for and responded to future cosmic discoveries. The encounter had provided valuable insights into the practical challenges of studying unusual phenomena, while highlighting the institutional and cultural evolution that might be needed to handle even more significant discoveries effectively. The story of 3I Atlas was ultimately a story about human curiosity and our perpetual quest to understand the universe around us. The encounter had demonstrated both the power of that curiosity and the importance of maintaining intellectual humility when confronting phenomena that might exceed our current conceptual capabilities. Whether 3I Atlas proved to be a natural comet with unusual characteristics or something far more extraordinary, its passage through our solar system had enriched human understanding in ways that extended far beyond any specific scientific discoveries. The object had challenged our assumptions, expanded our imagination, and reminded us that we inhabit a universe full of mystery and wonder. As 3I Atlas disappeared into the cosmic deep from which it had emerged, it carried with it our hopes, questions, and dreams about what might be possible in a universe where intelligence and consciousness might take forms we could barely imagine. The encounter had been a reminder that the greatest discoveries might not provide answers to our existing questions, but instead reveal entirely new questions we had never thought to ask. The mysterious visitor had given humanity a precious gift, a genuine encounter with the unknown that expanded our sense of cosmic possibility, while highlighting the importance of maintaining wonder, curiosity, and intellectual courage as we continue our eternal journey toward greater understanding of the vast and magnificent universe that surrounds us. In the end, 3I Atlas had served as both mirror and window, reflecting our own hopes and limitations, while offering glimpses of cosmic possibilities that stretched towards horizons we could barely perceive. The encounter had reminded us that we are part of something far grander and more mysterious than our daily experience might suggest, and that the next discovery might fundamentally transform our understanding of what it means to be conscious beings in an infinite cosmos filled with wonders beyond imagination. The gentle fading of 3I Atlas from our instruments marks not an ending but a beginning, as humanity turned toward the future with expanded awareness of cosmic possibility and renewed commitment to the eternal quest for understanding that defines our deepest nature as conscious beings capable of wonder, curiosity, and the persistent hope that somewhere among the stars, other minds might be looking back at us with similar questions about the nature of existence in this vast and beautiful universe we all share. And so we find ourselves here, at the end of our journey through the mystery of 3I Atlas, having explored every angle from rigorous science to wild speculation, from careful observation to profound philosophical implications. Tonight, as you settle into sleep, perhaps you might dream of ancient visitors carrying messages from distant suns, or of patient intelligences conducting surveys across cosmic time, or simply of the beautiful mystery that reminds us how much wonder still awaits discovery in our magnificent universe. The story of 3i Atlas teaches us that the cosmos still holds secrets capable of challenging our most sophisticated understanding, that the line between the natural and the artificial might be more fluid than we imagine, and that the universe might be far stranger and more wonderful than our current theories can encompass. Whether our mysterious visitor was a chunk of ancient ice from another star, or something far more extraordinary, it reminded us that we live in a reality where the impossible sometimes brushes against the everyday. As you drift toward dreams tonight, carry with you the sense of cosmic possibility that 3i Atlas brought to our world. Remember that above our heads, space stretches toward infinity, filled with objects and phenomena that might challenge everything we think we know about intelligence, consciousness, and our place in the grand design of existence. The questions raised by our interstellar visitor will continue to echo through scientific research and human imagination for decades to come. Each new discovery builds upon the insights gained from encounters like 3i Atlas, gradually expanding our understanding while simultaneously revealing how much mystery still surrounds us on all sides. Thank you for joining me on this gentle exploration of one of the most fascinating mysteries of our time. If these quiet scientific wanderings have brought you comfort and wonder, it would mean the world to me if you could share a kind, like and perhaps subscribe to join our growing families of curious dreamers who find peace in the beautiful questions that science brings to our lives. May your dreams tonight be filled with cosmic possibilities and peaceful wonder, and may you always remember that in a universe as vast and mysterious as ours, the next discovery might be the one that changes everything we think we know about reality itself. Sleep well, dream deep, and remember that the stars are always there, waiting patiently for curious minds to ask the next beautiful question that might unlock another piece of the cosmic puzzle that surrounds us all. Good night, fellow travellers in this magnificent cosmic mystery we call existence.